எங்க சார்ஜ் ஆயிருச்சு போது சார்ஜர் ரெண்டு பாக்குங்க கிரீன் கலர்ல இருக்குல்ல அது ரெண்டே பேக் நீங்க சவுண்ட் வருதா மட்டும் பாரு வீட்டுல ஒரு நிமிஷம் சவுண்ட் வருதா லைட் நிமிஷம் கழிச்சுதான் வரும் வருதான் இன்னொரு ஒரு விஷயம் அதுதானா இன்னொரு ஒரு விஷயம் டாப் பேக் போட்டுட்டு கேமரா முன்னாடி பேசாத அது ரெக்கார்ட் ஆகுது லைவ்ல போகுது சரியா என்ன விஷயமோ டாப் பேக்ல மட்டும் நான் சொல்றேன் அதை மட்டும் கேட்க அனாவசியமா பேசிடாத புரிஞ்சுதான் நேற்று அதை நான் நோட்டீஸ் பண்ணேன் தயவு செஞ்சு பேசிடாது மேம் ஆங்கிள் வைக்கவா அதை மட்டும் சொல்லு அது இல்லாம நீ பேசணும் ஏதாவது சப்போஸ் பேசணும் மைக் ஆஃப் பண்ணிட்டு பேசுங்க சரியா ரெக்கார்டு போட்டுட்டு என்கிட்ட சொல்லு நீங்க ஆடியோ கொடுத்துருக்கலாம் இல்ல 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 கரெக்ட் தான்
A pleasant morning to one and all present here. Respected dignitaries on the dais, distinguished chief guests, eminent scholars, faculty members, research participants, all those who are joining us through the live telecast, and my dear students. It is my proud privilege to welcome you all for the International Conference on Mathematical Innovation for a Sustainable Future 2026. The lighting of the lamp symbolizes the removal of darkness and the spread of knowledge, wisdom, and enlightenment. May I now request our esteemed dignitaries to kindly come forward for lighting the lamp. I now invite Reverend Dr. Sister Ignatius Mary, Secretary, Fatima College, to light the first wick of the lamp. Next, I invite our esteemed resource person, Dr. M. Rajesh Kannan, Associate Professor, Department of Mathematics, IIT Hyderabad, to light the second wick of the lamp. I now invite Mrs. Sheila Roslin, Assistant Professor, Head and Convener, Department of Mathematics, to light the third wick of the lamp. Also, I invite our organizing secretaries, Dr. V. Vanita and Mrs. Teresa Nirmala, to light the fourth and fifth wick of the lamp. Thank you, respected dignitaries. Prayer enlightens our minds and guides our efforts towards success. Every auspicious beginning seeks the blessings of the Almighty. To invoke God's gracious presence, I request our student choir to lead us in prayer. Thank you, dear students, for leading us in divine grace. Mathematics is the language in which the universe is written. From science and technology to economics, health and environmental studies, mathematics shapes the way we understand the world and engineer the future. At a time when sustainability has become a global priority, mathematical innovation serves as a powerful tool for building intelligent and transformative solutions. This conference brings together brilliant minds from various institutions and regions to share research, exchange ideas, and foster collaborations that pave the way for a better tomorrow. With this spirit, we begin the inaugural ceremony. A warm welcome reflects the spirit of hospitality and sets the tone for a meaningful gathering. It's my privilege to invite Mrs. A. Sheila Roslin, Assistant Professor, Head and Convener, Department of Mathematics, to welcome the gathering.
Lead kindly light. Good morning, distinguished guests, respected dignitaries, esteemed colleagues, research scholars, and my dear Fatimites. It is with great pleasure and deep respect I stand before you today to warmly welcome the distinguished Secretary of Fatima College, Reverend Dr. Sister Ignatius Mary. Your dedication, visionary leadership, and unwavering commitment to excellence have continually inspired confidence and progress within our organization. Under your guidance, we have witnessed growth and strengthened unity. Your integrity, wisdom, and tireless service set a standard that motivates us to strive for higher achievements. Dear sister, your presence among us is both an honor and a privilege. Welcome you, sister. I extend a warm and heartfelt welcome to the respected principal of Fatima College, Reverend Dr. Sister M. Fatima Mary, a true leader, mentor, and a guiding light whose positive vibration makes this occasion even more special. It's an honor and privilege to stand before you today as we gather to welcome an exceptional individual whose presence truly elevates this occasion. Today, we are graced by the presence of Dr. M. Rajesh Kannan, Associate Professor, Department of Mathematics, Indian Institute of Technology, Hyderabad, Telangana, a personality whose remarkable achievements has left an indelible mark in the field of education. His journey is not only inspiring but also a testament to vision, perseverance, and excellence. Sir has done his undergraduate and postgraduate in Anjua College, Subhasi. He did the doctorate of philosophy in IIT Madras and was a summer student in Department of Mathematics, the Technion Israel Institute of Technology, Haifa, Israel. As a postdoctoral fellow, he yielded Ramanujan's wisdom from professors staying in New Delhi, Israel, and Canada. Dr. Rajesh Kannan's area of research are spectral graph theory, matrix theory, functional analysis, etc., etc. He joined as an assistant professor in the Department of Mathematics, IIT Kharagpur, and now currently serving in IIT Hyderabad, Telangana. Sir has published more than 39, successfully guided 3 PhD students and 2 ongoing. Sir has 4 postdoctoral fellow students. He has organized more seminars and workshops and 8 awards sponsored projects. His academic achievements: Excellent Young Teacher Award 2020, IIT Kharagpur with 2 lakhs cash award, Postdoctorate Fellowship, University of Manitoba, Canada, Postdoctoral Fellowship under German-Israeli Foundation of Scientific and Research Development, Israel, Visiting Scientist Fellowship, Indian Statistical Institute, awarded full scholarship for attending the summer school in non-negative matrices and its applications by the Technion Israel Institute of Technology, Postdoctorate Fellowship, National Board for Higher Mathematics, qualified in the NBHM, CSIR, UGC, and GRADE Research Fellowship examinations. Grants and awards: served National Postdoctoral Fellowship, ANRF in 2023, 2024 and 2025, Core Research Grant, International Travel Support Grant, Seed Grant as Principal Investigator, SRC IIT Hyderabad, Matrix Principal Investigator, DSC served in 2017, 2018 and 2019, Early Career Research Award, served National Postdoctorate Fellowship, ISIRT Project, SRIC, IIT Kharagpur. Dr. Rajesh Kannan is a personality admired from Tamil Nadu to Canada, has inspired people across continents with a dedication and vision. Throughout the distinguished career, Dr. M. Rajesh Kannan has demonstrated an extraordinary commitment to innovation. Your remarkable career, dedication to academic excellence, and commitment in nurturing young minds have earned you deep respect and admiration. Over the years, research contributions and mentorship have not only enriched the institution, but have also inspired countless students and colleagues. You ignite curiosity, cultivate critical thinking, and guide others towards the highest potential. You have exemplified these qualities throughout your distinguished service. We are deeply honored that despite a demanding schedule, you have chosen to spend this valuable time with us. Your presence today signifies the importance of this gathering and reinforces the spirit of collaboration and excellence that we strive to uphold. On behalf of Fatima family, I extend a heartfelt welcome and sincere appreciation. We are truly honored by your presence and look forward to the insights, wisdom, and inspiration you will undoubtedly share with us. Welcome you, sir. I extend my heartfelt welcome to the Vice Principals, Dr. Sister J. Arulmeri, Dr. S. Vidya, Dr. Sister Bindu Anthony, and Mrs. Nigla Raghavan, who performs as the four pillars of Fatima College. I welcome the IQBC coordinator, Dr. Saira Banu, and the team for the efforts taken in all the college activities to reach greater heights. A very warm welcome to the faculty and the amazing Viscom department team whose efforts have made this YouTube live session possible. I welcome the faculties, research scholars, and the students of various institutions who aspire for the knowledge and have thirst for research. With heartfelt joy, I welcome my dear friends in the Department of Mathematics whose tireless work and deep commitment fill with pride and gratitude. I welcome the non-teaching staff for the support given for the conduct of the program. Finally, I welcome our dear Fatimites for the wonders they do to reach the greater heights. Today, let us learn from one another, inspire one another, and leave the conference enriched with ideas and motivation. Once again, I welcome you all. Welcome.
Thank you, ma'am, for your warm and gracious welcome. As a mark of our love, respect, and appreciation, we shall now honor our esteemed resource person. May I request Reverend Dr. Sister Ignatius Mary to kindly honor Dr. M. Rajesh Kannan with a shawl. Thank you, sister. Warm welcome to you once again, sir. The inaugural address lays the foundation for the purpose and vision of the conference. It is my proud privilege to invite Reverend Dr. Sister Ignatius Mary, Secretary, Fatima College, to deliver the inaugural address.
A very good morning to all of you. Respected chief guest, the brilliant chief guest, because we heard from the welcome address his enormous achievement and what a great person he is, though in appearance he looks very simple and humble. So this is what Yes, he is going to give he is the keynote speaker, Dr. M. Rajesh Kannan, Associate Professor, Department of Mathematics, IIT Hyderabad, and special speakers, Dr. Prabhu Nadarajan, Assistant Professor, Department of Mathematics, College of Computing and Information Science, University of Technology and Applied Sciences, Sultanate of Oman, Dr. S. Lalitambige, Assistant Professor, School of Mathematics, Madurai Kamaraj University, committed Head of the Department of Mathematics, Mrs. Sheila Roslin, detail-oriented organizers, scholarly paper presenters, participants from different colleges, and my dear students, a very good morning to all of you. I feel very proud of the Department of Mathematics who has organized this international conference to examine the various ways that mathematical ideas and methods could promote sustainability on a worldwide scale. This international conference may highlight how important mathematics is in forming sustainable practices and the constant need to modify and advance mathematical techniques to deal with new world concern. I congratulate the department for inviting very learned and efficient speakers to deal with such relevant topics in keeping in line with United Nations 17 Sustainable Development Goals. On September 2015, the General Assembly of the United Nations has adopted the 2030 Agenda for Sustainable Development, such as the efforts to reduce poverty, improve education, and advance healthcare. Statistical analysis make it easier to track progress. I am sure that the paper presenters deal with efficiency and sustainability that are promoted by sophisticated mathematical algorithm used in urban planning and renewable energy systems. Since the conference is a hybrid mode, multidisciplinary application highlight how mathematics may be used to tackle difficult problems like disaster, risk reduction, and biodiversity protection. Keynote approaches include climate modeling, renewable energy, grid optimization, resource management, and biodiversity tracking, often utilizing AI and big data. These tools allow for evidence-based decision-making in sustainable agriculture, circular economy practices, and ecological resilience. By stimulating and predicting environmental changes, mathematical modeling provides insight into techniques for mitigating climate change. To improve resource allocation and strike a balance between environmental protection and economic growth, optimization techniques are used. For a number of sustainable development goals, mathematics is a crucial tool for addressing the complex and interconnected issues. In many domains, such as data analysis, resource allocation optimization, and environmental system modeling, mathematics provides the essential foundation for innovative and sustainable solutions. Differential equations and simulation models are used to forecast climate changes and assess environmental impacts. Mathematical models help to analyze species interactions and the impact of climate change on biodiversity. Algorithm determines the optimal mix of solar, wind, hydro, and biomass energy for maximum efficiency. Models maximize crop yield while reducing water, fertilizer, and pesticide usage, analyzing massive data sets to monitor energy consumption and environmental trends. AI models are improving in solving complex symbolic equations, including those in differential equation and calculus, which are essential for engineering and science. Mathematics has future career paths that included machine learning, engineering, data scientist, AI research scientist, quantitative analyst, computer, vision engineer, robotics, natural language processing engineer, and AI ethicist. Mathematical tools analyze large data sets to extract insight, develop predictive models, and guard business decisions. Its interdisciplinary uses, which have enhanced fields like biodiversity, protection, urban planning, renewable energy, and climate research. However, there are changes when using mathematics to tackle real-world issues. Data limits, ethical considerations, and the need for interdisciplinary collaboration highlight the importance of responsible and inclusive approaches. The pride of mathematics extends the future trends with AI to act as a collaborative partner, generating new mathematical conjunctures. Let us explore mathematics with confidence, embracing both ethical responsibilities and its boundless potential creativity and discovery. I wish you all the best. May this conference take you to greater heights of research, development for the country and the universe at large. Wish you all the best. Thank you.
Thank you, sister, for your inspiring and motivating words. Your guidance encourages us to strive for excellence. The keynote address is the intellectual compass of any conference, guiding the discussions that follow. When we think of mathematics, we often picture blackboards covered in abstract equations. Yet, our resource person has spent their career proving that mathematics is not just the language of the universe, it is the language of innovation. May I now invite our esteemed resource person, Dr. M. Rajesh Kannan, Associate Professor, Department of Mathematics, Indian Institute of Technology, Hyderabad, Telangana, to kindly deliver the keynote address.
Okay, so good morning, everybody. First of all, I thank the organizers for the invitation, and I don't know, she gave over hype to my profile. Yeah, it's like I'm not that big guy. Okay, so I think most of you are doing math and statistics. Okay, so I'll just emphasize like there are a lot of opportunities for people those who are doing math and statistics. Okay, I think most of you may know the booming industry, data science. The fundamentals of data science, if you have to understand, like math and statistics are the key objects. Okay, so to be specific, if you are doing the course on linear algebra, linear programming, or real analysis, probability statistics, okay, try to understand those subjects from the scratch and try to solve all the problems in the book. Okay, so and then I'm surprised to hear sister's talk. Like what I have to do, maybe as a keynote speaker, what I had to speak. I think she spoke many of the things. She's talked about data science. She's talked about many applications of like what we are doing in math. So in my talk, like I will try to illustrate. I've chosen three data science problems. We'll try to solve those problems using mathematical tools. Okay. So if you want me to talk mathematics for an hour, I can talk, but keynote, I don't know. Okay. I'm not sure. Okay. It's okay. I'll stop here. Okay. Yeah.
Thank you very much, sir, for that illuminating and intellectual short, truly insights that truly inspired us. Gratitude is the sign of noble hearts. I invite Mrs. Teresa Nirmala, Associate Professor, Department of Mathematics, to deliver the vote of thanks.
Distinguished dignitaries on the dais and dear participants, as we come to the close of this auspicious inaugural ceremony, it's my pleasant duty to propose the vote of thanks. An inauguration is not merely the opening of an event, it is the affirmation of a vision, the renewal of hope, and the celebration of collective hard work. First and foremost, I express our heartfelt gratitude to our Secretary, Dr. Sister Ignatius Mary, for graciously inaugurating this event. Your inspiring words and valuable insights have set the perfect tone for the sessions ahead. We are truly honored by your presence and thankful for your encouragement and guidance. Thank you, Sister. With the highest regard, we express our sincere thanks to our principal, Dr. Sister M. Fatima Mary, whose unwavering dedication and strong ethics remains the cornerstone of our success. Thank you, Sister, for guiding us with grace. With immense gratitude and heartfelt appreciation, I extend our sincere thanks to our esteemed chief guest, Dr. M. Rajesh Kannan, Associate Professor, Department of Mathematics, Indian Institute of Technology, Hyderabad, Telangana. Your distinguished presence has truly elevated the significance of this event and inspired us all. The time you have taken from your valuable schedule to be with us today means a great deal to our entire organization. We are deeply honored by your encouraging words and thoughtful insights, which have set a positive and meaningful tone for this initiative. Your support and blessings is not just the beginning of this program, but the beginning of the new opportunities and aspirations. Thank you once again for lighting the lamp of knowledge and inaugurating this event. Finally, I thank each and everyone who joined us today, both those present here in person and those who have joined us virtually, for being part of this significant beginning. Your presence has added meaning and strength to this event. With gratitude in our hearts and enthusiasm for the journey ahead, I once again thank you all. Have a wonderful and productive event ahead. Thank you.
Let's continue the conference with renewed enthusiasm and academic spirit. We shall now begin session 1 with great honor. I now invite Let's continue the conference with renewed enthusiasm and academic spirit. We shall now begin session 1 with great honor. I now invite Dr. Mr. Rajesh Kannan to take over the session. The floor is yours, sir.
Students, I invite all the participants from other institution to come forward for taking photos. Students, kindly come to the stage. I repeat, I invite all the participants from other institution to come forward for taking photos.
The other college participants and my dear colleagues, please come forward.
Good morning. Yeah. So, can you see the slides? Is it readable? Okay. So, I'll be talking about applications of linear algebra. It's a vast topic. Like we can offer a course based on this topic. Okay. Applications of linear algebra. So today I will just talk about 3 problems which arises in data science and machine learning. How to handle these problems using linear algebra methods. Okay. These are kind of classical methods. Okay. So in order to understand the modern methods, what is happening in the machine learning and data science industry, you should know like the classical methods or the basics of linear algebra rigorously. Okay. So the aim of this talk is to introduce some of the methods. Okay. Rigorously. Okay. By rigor, I mean like what is the mathematics behind it, I will try to explain. Okay. So the allotted time for me is from 10 to 11:15. I'll try to stop at 11. Okay. I have 40 slides. I don't have any intention to complete all the 40 slides. We'll go slowly. Okay. If you have any doubt, you can stop me. We can ask the organizer to give one mic to audience. If you have any doubt, you can stop and ask me. Okay. Okay. First thing. Full up. Okay. So many of you might have seen this problem, image compression. If you don't know, don't worry. I'm going to explain what is the problem. Okay. So suppose you have an image, let's say a photo. Okay. Size of the image is really high. Okay. You want to reduce the size of the image without reducing the resolution. or the quality of the photo much. Okay. So of course, if you have to reduce the size of the file, then you have to lose something. Okay. The quality, there will be obviously a reduction in the quality. Okay. But with a reasonable good quality, okay, how to do that? So the problem is, so we have to like reduce the amount of data required to store the image or transmit the image, okay, through some channel. So the digital images, when you see, those things are nothing but matrices. Okay, whether it is a color image or it's a black and white image pictures. So they are all just matrices. So I'll explain like how the images are stored in computers. Okay, and for those matrices, how to apply the linear algebra technique to reduce the size of the image. Okay. Okay, so you can read that the story what I have written there. This is just a motivation. This is the problem. This is one of the problem which you are considering. Okay, the key point is I had to reduce the size of the image. Okay, without reducing the quality much. Okay, with a decent quality. Okay, the second problem is, so handwritten digit classification. Okay, so nowadays when you are writing something. Okay, so all our signatures or our writings need not be uniform. Okay, for an example, one can write a number 2 like almost like Z. Okay, someone may write 2 like that one circle, start with a circle and then complete your 2. Okay, so like that, like you may write down the digits in different ways. The problem of handwritten digit classification is, so this is a real life problem. This is a fundamental problem in pattern recognition and machine learning. So you have to automatically classify the digits. Okay, that means that I will give you the handwritten digits of someone. Okay, so you have to scan it and you have to say whether the number is 0 or 1 or 2 or and so on 9. Okay, you means like if I give it to you, you can obviously by looking at it you will tell. By you I mean the computer. Okay, so you have to write. You have to the computer has to automatically recognize whether the digit is 0 or 1 or 9. Okay, so how to do that? So we will be we'll use techniques from linear algebra. So every image, again, it can be a black. Let us assume that's a black and white image. It can be stored as a vector. Okay, I will explain how to convert the digit representation into a vector. Okay. Like similar to the image conversion what you have done. Okay, and we will try to extract the important features of the letters. Okay, by important features like something involving kind of eigenvalues and eigenvectors, I will tell you. Okay, and how to use them to classify unknown digit. Okay, so if you are comfortable with the machine learning terminology, like we have something called the training set and we have something called test set. Okay, so using the training set, you have to form an algorithm or some sort of heuristic, so that when you are giving or feeding a new digit, okay, your algorithm or heuristic should return the correct answer. Okay, so we may not be able to find out or develop an algorithm which works 100%. Okay, that's most of the problems. It's not possible. It's impossible. Okay, almost always. Okay, kind of 90% or more than 90%. How to get it? So there are various methods are available for this problem, handwritten digit classification problem. Okay, just you can Google it. You can find out. I think at least 3 or 4 types of methods you can find. Okay, so today I will focus on one of the classical methods using the singular value decomposition. Okay, this is the second problem I want to address. Okay, and the third problem is the clustering problem. So this is one of the like a core problem in with data science. Okay, so I will give you a set of points. Data I will give it to you. You have to cluster the data into groups. Okay, based on some sort of similarities. Okay. So this is very commonly used. For an example, if you see, like if you are watching a movie in Netflix, or if you are buying some product in Amazon. Okay. So after you bought the product, you will get a number of notifications from Amazon. Okay. For an example, if you bought a book on real analysis, let us say by Rudin, if you buy, what are the other products you can expect from Amazon in the recommended area? Okay, something which you might have bought, related to that it will come. Okay, that also related to what you or your friends are buying. Okay, how they are doing it. And the net, if you see, if you watch certain movies, then it will give you some suggestions. Okay, how it gives you the suggestions. And YouTube, recommended videos, how it recommends the videos. You're watching, let's say 10 Ilayaraja songs, and the 11th song will be, mostly it will be a Ilayaraja song, it will be recommended to you. How it works. Okay, so basically every problem has a solution or approximate solution using linear algebra. Okay. Even Google, I think all of you know what is Google. Okay, how Google works. Any one of you know how Google works? Okay, so the Google, the basic idea behind is just a eigenvalue, eigenvector problem. Okay, so you have to find out the eigenvalue and eigenvector of a large matrix. Okay, okay, I'm not going to those details. Okay, this is a like a real life problem in data science people are facing. I'll give you points. This n is arbitrary large. It can be billion, more than billion. Okay, so I have to group them into smaller collections. Okay, maybe 100 collections or 1,000 collections. How to do that? Okay, don't have any kind of algorithm run to solve this problem. I will end it with some again some linear algebra tool that will help us in solving the clustering problem. Okay. So these three problems I will try to focus. Okay. So do you have any doubt on these problems before moving to the solution or how we are going to solve these problems? The problems are clear. First of all, this is a first step you have to understand. Okay, when you are trying to solve a problem, you should understand the problem. If you don't understand the problem, then what are you going to solve? Okay. So these are the three problems we are focusing. One is, what is the first problem? Image compression. Okay, we are compress the image size of, we are going to reduce the size of the image without losing the quality much. Okay. And the second problem is handwritten digit classification. That means like you have a collection of data with you. The data, like data means like you have collection of various ways of writing the digits 0 to 9. Okay. So using those data, if I give you a new number, you have to identify or you have to classify whether the number is 0 or 1 or 2 or 3 and so on. Okay. So here I again emphasize, you means not you, it's a computer. Okay. Can't think much. A third problem is, we will give you a clustering problem. Okay. So we will give a group of data. Okay. The data can be anything. Okay. And we will give some sort of similarity measure. So you have to compare the data using some measure. So this is just a measure means plain English word. There is no measure theory. Okay. So measure, using that measure, you have to group them into several groups. Okay. The simplest example maybe here in this hall itself we can take. So you can group the students based on, or all participants based on their heights. Okay. Those who are with the height of 175 centimeter to 180 centimeter, we can group them. Okay. 170 to 175, 165 to 170, 160 to 165 and so on. So this the similarity measure here, it is something like the height. In terms of height, we are forming the groups. Okay. So let us move on to the mathematical part. Next. So singular value decomposition. This is one of the fundamental theorem which we used to study in an advanced course in linear algebra, maybe in a master's MSc course in linear algebra. So among the students or research scholars, how many of you know this theorem already? Singular value decomposition. Students or research scholars. Okay, so if you don't know, like if you want to really do data science, or if you are interested in taking career in data science, with the math background, like this is one of the fundamental tool you have to, you should know or you have to understand. Okay. So, like I will explain these things mathematically, and there are a number of websites where you can look into kind of layman understanding of this thing. Okay. So how to explain this? So to start with, I'll start with a rectangular matrix. Okay. So R can be A can be a like a 1000 by 2000 matrix or 2000 by 1000 matrix. Any matrix you start. Okay. So can we talk about the eigenvalues of a rectangular matrix? So we don't have a notion of eigenvalues and eigenvectors for rectangular matrix. Okay. So in your BSc you might have studied eigenvalues of square matrices. Okay. So now we will study some sort of eigenvalues and eigenvectors for rectangular matrices. Okay. So if you give me any rectangular matrix, then I can decompose the matrix into a matrix of this form. A equal to U sigma with some zeros and V transpose, where sigma is a kind of diagonal matrix whose the diagonal entries are some sigma i's. Okay. The property of U and V are they are orthogonal matrices. Okay. What is an orthogonal matrix? The inverse of the matrix is its transpose. Okay. So the advantage of having this type of decomposition is, so you can completely like kind of say what the matrix or how the matrix operates on the vectors. Okay, I will just explain you geometrically what is this. Okay, so before that, some terminologies. The matrix U is called the left singular vector matrix and V is called the right singular vector matrix. Sigma i's are or sigma j's are called the singular values. Okay, the singular values will play crucial role in many of the applications. Okay, so the high level what I'm going to do today is, as I said, these images and digits can be represented by matrices. Okay, for each of those matrices, we will calculate this decomposition. Okay, the so-called singular value decomposition. The approximation in one line, what we are going to do, okay, or how we are going to reduce the image size of the image is, you have to chop out many of the sigma i's. Okay, so what do I mean by that? So suppose I have, let us say n equal to, I have 500 singular values, 500 non-zero singular values. I don't have to keep all the singular values with me. I'll just keep either 20 or 30 singular values. Okay, I'll explain that will reduce the calculations or computation efficiently, and still we will get some reasonable image resolution or reasonable classification for digits. Okay, for first two problems, SVD is the key. Okay, so SVD or singular value decomposition. Okay, yeah, this you can skip. Next. Okay, so first of all, I'm not going to read the proof. Okay, I don't want to bore you with the proof. So I'm saying something. You give me a matrix. I'm saying you can write down that matrix in the form U sigma V transpose. Okay, as a mathematician, you should ask the question: how do I know such type of decomposition exists? Okay, so the course in linear algebra, you can prove even A is an arbitrary matrix. If you consider A transpose or A transpose A, both the matrices are symmetric matrices. Symmetric matrices you can diagonalize. Okay, so using the diagonalization, you can get a proof for the singular value decomposition. So the first issue is the existence issue. So existence problem is solved. You give me any matrix, any finite matrix, I can write down that as a I can show that it does has a singular value decomposition. Okay, so when you are trying to do the things, or when you are trying to implement something in the computer, existence of certain thing will not solve the purpose. Okay, so I may be able to show every matrix has this type of decomposition, but how to calculate it? Okay, the simplest problem is, like, I will give you a polynomial of degree 5. Okay, so from your school days, you may know like how to find out roots of a polynomial. If I give you a polynomial of, how do you calculate the roots of the polynomial? So for a quadratic equation, how do you solve? If the polynomial is of degree 2, then how do you find out the roots of the polynomial? Very simple question, okay? So 3. So how many of you know proper method to calculate roots of a third degree polynomial? Huh? You know something, okay? What about fourth degree? Only students and scholars, can you raise your hand as how to solve or how to find out all the roots of a fourth degree polynomial? Do you know any method or? Okay, so some yes sir. Okay, okay, I assume you know it. Okay, what about the fifth degree polynomial? If I give you a fifth degree polynomial, can you find all the roots of the polynomial? Do you know any method to calculate all the roots of the fifth degree polynomial? Huh? So how many of you are completed your MSc or in your second year of MSc? You might have studied a theorem called fundamental theorem of Galois theory or Galois theorem. Okay. So we don't have any algorithm or a exact analytical method to find out all the roots of a polynomial of degree more than 5, including degree 5. Okay. So likewise, we don't have analytics or we don't have any algorithm to solve all the mathematical problems. Okay. The same issue or the same complexity is applicable to eigenvalues. How do you calculate the eigenvalues? How do you calculate values? So singular values are nothing but eigenvalues, some matrix A transpose or A transpose A. So how do you calculate the eigenvalues? The characteristic polynomial you will find, if the size of the matrix more than 5, then the degree of the characteristic polynomial is more than 5. So you don't have any efficient method or you don't have any analytic method to find all the roots. So you have to go for some numerical methods. Okay. So there comes the numerical course. What are the numerical techniques you know to find out eigenvalues of a matrix? Huh? Power method you can use. Okay, power method give you an efficient way to calculate the largest eigenvalue. Okay, if it is simple. Okay, and so on. So all these things are useful in solving this type of problems. Okay. So coming back to singular value decomposition, we do have some efficient methods to calculate of the matrix. Okay, not exactly, maybe up to the given accuracy you can calculate. So existence as well as algorithmically also one can show that one can calculate this SVD, okay, efficiently. Okay, so now how to use these things? Is this figure visible first? So as I told, like if you take a matrix A, if you operate a vector on the matrix A, that is X is a vector, A is the matrix, then what is happening to AX? Okay, if you know the SVD of the matrix, singular value decomposition of the matrix, you can visualize what is happening in the like the vector matrix multiplication. So let us take two vectors V1 and V2 on the unit circle. By unit circle I mean the length of the vectors which are sitting in the circle are equal to 1. Okay, think of just R2. Okay, R2 points like 1, 0, 0, 1, 1 by root 2, 1 by root 2, those type of points you see. Okay, so you take two linearly independent vectors V1 and V2. So A is an arbitrary matrix. Okay, so we have seen that it admits a singular value decomposition. That means that A can be written as A equal to UD V transpose. Okay, so V is an orthogonal matrix. That means that that's not going to change the length of the vector. When you're applying that matrix on a vector, the orthogonal matrices will not change the length of the vector. They will just rotate the vector. That's all. Okay. So the second figure, if you can see, there is an arrow. Multiplication by V transpose that will just rotate the vectors V1 and V2. Okay. After that, when you do the diagonal multiplication, okay, so that is going to scale the entries of the vector. Okay. So how does it get scaled? The scaling factor is given by the singular values. Okay. And again, if you multiply by u is an orthogonal matrix. Hence, that is going to rotate the vectors. Okay. The one line conclusion or outcome of this discussion is, if you take a circle in R2, okay, if you apply the matrix A for the circle, okay, that means for all the points on the circle, if you apply your matrix A, the circles are getting transformed to ellipse. Okay, you have maybe in a first course in linear algebra, you might have observed those things. Okay, so now using singular value decomposition, you can see what is happening explicitly. Okay, so next. So just if the previous slide was not visible, then just instead of going to 4 figures, I'm giving 2. If you take a unit circle, if you apply the matrix A to it, the image of the circle will be an ellipse. Okay, it can be a degenerate ellipse. By degenerate ellipse, I mean it may be a line. Okay, where this what are the axes for the ellipse? So sigma 1 and sigma 2, those are the singular values. They gives the magnification or contraction factors. Okay. So these are all basic fundamental objects which is known to people long time. So these objects play crucial role in the application part. Okay. So you will see how to apply. You can move on. Next, this one. Okay, let's go back. So, suppose if you are really want to plan some linear algebra and applications, if you might have given a try in, if you might have searched for these applications of linear algebra, you might have seen one video lecture from MIT by Gilbert Strang. Okay, so he has written a fantastic book on linear algebra. If you want to study what are the applications of linear algebra, I strongly suggest you to go through the book. So he calls this 4 subspaces as 4 fundamental subspaces. Given a matrix A, one can associate 4 matrices, 4 spaces. One is called range space of A, null space of A, range space of A transpose, null space of A transpose. Okay. So if you are in MSc, like after a linear algebra course, like you can see these things. Okay. So when you have subspaces, it is natural to ask, can you give me the basis for the subspaces explicitly? If you know the SVD, then the singular value decomposition, then you can read out the basis of the spaces explicitly using the singular value decomposition. Okay, so you know the matrices U and V. Okay, so the range space of A is just a span of U1 to UR, and the null space of A is then the span of VR plus 1 to VM. Okay, where R is the rank of the matrix. Okay. So, this is one theoretical advantage of having SVD with us. Okay, yeah. So, as a byproduct, like I think most of you know or at least heard this term, rank nullity theorem. Okay, so if you assume the singular, then the proof of the rank nullity theorem is just one line. You just try to convince yourself. Read out the dimension of range of A. Dimension of range of A is R there, and then the dimension of the null space, that's the nullity of A, that is M minus R. Okay. Okay, you can skip this. It's just an illustration. You take a rectangular matrix, how to do that. Okay, one more stroke. Okay. So, when you are looking at the singular value decomposition from the application point of view, so this is one equivalent representation which is very much useful. So this is nothing but just I'm expanding the notation. U sigma V transpose whatever I have written. It's just a basic linear algebra exercise. If you just write down that matrix multiplication U sigma V transpose, you can write down in this way: summation j equal to 1 to R sigma j uj vj transpose. Okay. So in this terminology, so what are we going to do? given an image, I will associate a matrix, which I will explain. Okay. So the approximating image or approximating the matrix is obtained from this expression by keeping only first, let us say, S terms of this summation. Okay, S can be arbitrarily small in compared to R. Okay, I'll do an explicit calculation to illustrate why this is a powerful tool. Okay, next. Yeah, so you can see that this is a result of Eckert and Young in 1936. So this is the kind of theoretical evidence or proof why TD should work. Okay, you can convince yourself that if A has rank R, okay, so you have done a course on linear algebra, most of you. The set of all n by n matrices will form a vector space. Okay, so inside the vector space, you consider a matrix of rank K. Okay. Okay, matrix of rank R. Rank of A is R. Then look at the subset of matrices which are having rank K. Okay, whose rank is strictly less than rank of A. Okay, where K is strictly less than rank of A. Then in set of all n by n matrices, you can induce a metric also. Okay, just you try to find out the distance between the set of all rank K matrices to the given matrix A. Okay, that is the distance is given by the K plus 1 singular value. Okay, and in fact you can say what is the matrix which is going to attain the distance. Okay, so the matrix which is attaining the distance is going to help us in the image compression thing. Okay, exactly the image corresponding to this AK is going to be our the image which you are expecting to have low size. Okay, move. Okay, so far if you didn't understand some of the things, you don't have to worry. Okay, just those are all the theoretical part and the mathematical thing. So this is not a heavy math content. Okay, just a real life problem how to convert. So if you have a grayscale image, that's a black and white image. Okay, if you have image of size m by n, so you have an image. How to think of that as a matrix? When you magnify an image in your using your the scrolling option in the mouse, what will you see after some time when you are keep on scrolling, when you are keep on enlarging the image? After some time, what will happen? Have you tried that when you are looking at the image, when you are keep scrolling in, like if you are magnifying, what will happen? Have you tried or? You'll find some squares, small squares, where each square cell consists of some color. Okay, in a black and white scale, like in a gray scale, like something like black and white, some amount of black and some amount of white, their combination will be there. Okay, so in that way, every grayscale image, okay, which is consist of some squares. Okay, so every square has some value. Okay, you can think of that as a value in between 0 and 1. 0 stands for black, 1 stands for white. Suppose 0.5 is there, then 50% of black mixed with the 50% of white, and so on. Okay, so in this way you are representing a image as a matrix. This is the first important point. Okay, you don't need any math to understand this. You are taking a picture. When you look at the picture, so how the images are stored? That's the question. It is stored in the matrix format. The matrix is obtained in this way. So in those pixels, like you say, the neighboring pixels are highly correlated. Okay, so neighboring pictures cannot change the color abruptly. Okay, so there should be some correlation between them. We are going to exploit that correlation in order to reduce the size of the matrix. Okay. So we'll see how are you going to. Yeah. So this is the idea. I have associated a matrix with it. Compute the singular value decomposition. Okay. So A equal to U sigma V transpose. Equivalently, you can write on that as summation I equal to 1 to R sigma I Ui Vi transpose. Okay. So this is the entire matrix. I don't want the entire matrix. What I will do, next, I'll just take only first k singular vectors. singular values. Okay, so you don't have to take every R of them. Okay, R can be 1 lakh, or it can be million, or it can be billion. You don't have to take everything. You can just focus on first 100 terms or 1000 terms. Okay. With that, I will get this expression which is given in the box. AK equal to summation I equal to 1 to K sigma I U I transpose. Now, instead of storing the matrix AK as such, I will store only the matrices UK, sigma K and VK. Okay. So previously I had an image of size M by N. Okay. So that means M total M pixels will be there. Now after reducing the size of the matrix using this calculation, we can significantly reduce it. Next. So initially I had to store all the Mn entries. Now after doing this calculation, I don't have to store like all the Mn entries. It is good enough to store K into M plus N plus 1. Okay. That's a school calculation, like a size of the UK, size of sigma K, and in sigma K also you don't need you don't need to store everything. Only the diagonal entries are good enough. If like M and N are really large and K is small, you can convince yourself that this K into M plus N plus 1 will be very small, okay, compared to Mn. Okay. Yeah, move on. Okay, so this is the interpretation. Mathematical interpretation is you are starting with a matrix. You are just looking at the rank K approximation of the matrix. The rank K approximation in real life, it means that compressed image. Okay, the compression happened. Reason or why are you saying compression is happening? Instead of storing M1 objects, I am store only K into M plus N plus 1 objects, which is relatively small. Okay, next. Okay, so for black and white image it works. What about color images? So for color images, we have various techniques. This is one of the classical technique. Nowadays, you have the notion of tensors and eigenvalues of tensors. People are using. So this can be thought of as is RGP, red, I think red, green, blue, red, gray, blue. I don't remember. Okay, so you just consider the intensities of red, green, and blue separately. You calculate 3 matrices, compute the singular value decomposition for all these 3 matrices. So using that, you can do a reduction in color images also. Okay, next. So that's kind of motivating example. Suppose if you have a 512 by 512 image, then the original storage you need like a 2,62,144 pixels. Okay, those many pixels to have the original image. After doing SVD, like it is good enough to store only for even for K equal to 50, it's enough to we need only 51,000. If you want to reduce your K further, you may have to lose some quality, but still you can store them in an efficient way. Okay. Okay, so this is just a summary. So SVD provides an optimal low rank approximation in terms of matrices. The low rank matrix, what you are getting, that's going to give you the compressed image. Okay. Okay, so I taught a course on in IIT Kharagpur. I was working in Kharagpur for 6 years. So that time I wrote a code for singular value decomposition in Python. Okay. So you can see the last image and the first image. Okay. The first image is the original one. Okay. I just started with the black and white image. That's the emblem of IIT Kharagpur. Okay. You can see that. So I converted that into a matrix using the rule which I told you. Okay. And they calculate the singular value decomposition of the matrix. The second one, which is next to that, the very clear one, the blurred one, that with I think K equal to 5. If you take top 5 singular values, then this is what you can get. Okay. If you are not worried about the quality, just you want to see what is there in the image. Those who know already how this Kharagpur emblem look like, they may figure out this is Kharagpur thing. Okay. If you are not still happy, I want more quality image. then I have taken k equal to 10. Okay. The size of the original matrix can be 1000. I'll take only rank 5 approximation to it. Then I'm getting a reasonable image. Okay. And then around rank 25 or 30 itself, you can reach the last one. Okay. It's really hard to distinguish between the figure 1 and the sixth figure here. The first one, like we have to store everything in the day, everything about the image. The last one, like I had taken hardly like first 50 singular values of the matrix. I have found out a rank 50 approximation to the image. Like I say, like from here, it's really hard to distinguish whether these two images are different or not. Okay, so I'm good with this. Okay, so this is one of the real life application of singular value decomposition, the image compression. Okay, any question? Okay, so it's 10:40. I have 20 more minutes. The second application. So the slides will be with you. Okay, and I have this is just a compressed version. Okay, I have an elaborate version of all these things in my web page. Interested? You can visit my web page. You can see I offered a course on computational linear algebra in 2019. Yeah, 2019 autumn I offered this course. You can find out the materials over there. Whatever I'm discussing, you'll find out a rigorous proof of everything in my web page. I mean, like only all the results will be there. The references you will find out all the proofs. Okay. So the second application. So handwritten digit classification in a similar line. Okay, I am going to apply SVD to some images or some matrix. Using that SVD or using that the matrices which I'm obtaining in SVD, how to classify this? Okay. So this is again one of the important problem in data science and in pattern recognition. So as I told you, like 2, someone can write 2 like Z. The first 2, if you see, that looks like some Z, and then you can see all the variations. Okay. So everything will be stored in a computer. To the computer, I will feed a new digit. Okay. Which computer don't know. Just it has to classify the newly feeded number or the digit as either 0 or 1 or 2 or 9. Okay. It has to apply the algorithm or the heuristic feeder to you. How to do that? Okay. So this is called US Postal. Some database is there. From there we have taken. Okay. So what you will do, since all of you are doing mathematics, I already gave you enough hint or motivation. These zeros, like every image, you look at first 0. Okay, you can think of that as a matrix. How do you think of that as a matrix? It is just a matrix whose entries are in between 0 and 1. Okay, starting from white to block. Okay, for block you give 0, for white you will give 1, or vice versa, and then fill the intermediate matrix. So likewise, you can, for every 0 you can associate a matrix. Okay, you can add all the matrix, or you can do some calculation with that matrix, and then when you are giving a new set, new number, for that number you will get again a matrix. Try to measure the distance between them. Okay, between the digits, other digits and the new digit. Okay, the distance, if it is very close to some digit, then you may announce that as the like possible digits. Okay, that is the common sense. Next slide. Move. So yeah, so this is the kind of, if you don't have much math background, you may do these things. Okay, for every image, you measure the distance from the new image to the matrix which I associated with the old images. Okay, and measure the distance which is close to it. You announce that may be the possible digits. Okay, fortunately that need not be optimal one or an kind of sensible one to do that. You have some more things. As like the last para, you can see like the clusters. By cluster I mean like you think of this the same digit written different way when you are associating vectors with it, you can think of all those vectors are forming clusters. Okay, you have to measure the distance between the new digit representation to the clusters. Okay, so we can use SVD. Yeah. Next. So if you take a combination of like all the ones or all the twos which are given to you, an average matrix, you can think of kind of average matrix looks like this. When the new digit comes, look at the image, the matrix of the image, okay, or the vector representation of that image, and then you see which one is closer. You assume that's the digit. Okay, this can be done in a more efficient way. That's what I'm going to discuss. So this explains kind of what I told you. Like you take some sort of average or mean of all the digits things. So for some tests, the success rate for this naive algorithm is 75%. Okay, so 1/4 of the time it's going to give you the wrong answer. Okay, but one can use a SVD, singular value decomposition, whose success rate is around 93%. This is quite old, maybe now efficient, more efficient algorithms. So I think one can go further. Okay. Yeah. Project. I thought I will have a pointer. I can do one by one now. No. Project. Yeah. So what do you do? Suppose if you have the digit, okay, as I said, that's going to give you a matrix representation. Okay, you assume that the matrix is a 16 by 16 matrix. To make our life simple, okay, let us take only a 16 by 16 matrix. So I want to represent that matrix as a vector. This is a usual procedure. If you are working in Python or MATLAB, you might have seen how to make a matrix into a vector. Just you can vectorize it. How to vectorize it? All the columns, okay, I put them one below the other. (16 by 16 matrix). Then something is gone. Okay. So it's possible to. Okay. So okay. Anyway, I will explain the first part. I can tell what we have done. So if it is a 16 by 16 matrix, how many entries are there? 16 into 16, that is 250 entries will be there. So you take the first column, okay, form your vector as follows. First keep the first column, then below the first column keep the second column, then below the second column keep the third column, and so you are going to get a vector of size 256 by 1. Okay, suppose assume that you have n such digits. Okay, then you keep the columns associated with each letter next to each other. Okay, each letter in the sense that if I am considering 3, just to consider all the like this 256 by 1 size 3's, the vectors associated with 3's in columns. Okay, then apply SVD to that matrix. Okay, so likewise you will get 10 different matrices. For all the 10 different matrices, you apply the SVD, singular value decomposition. Okay, look at the space which is generated by the left singular vectors. Okay, left singular vectors means the matrix U. I'm not going into the details of this. Okay, so using that you can classify the unknown digits. Okay, when the new unknown digit comes, it's a matrix. Convert that to a 256 by 1 vector. Okay, left singular vectors for every such matrices. Okay, they will span some subspace. Okay, here the thing is like even I don't have to take all the columns of your this thing. Okay, you can chop out something also. One can do that. Okay. So ideally you have to just measure the distance between the space generated by the left singular vectors to the vector which you are obtaining new. Okay. So this is the high level idea of how to classify the handwritten digits. Okay. So all these things can be efficiently implemented. One can implement in Python. Okay. If any one of you interested in data science or machine learning, I think either R or Python you should know. So all these things, whatever I said, most of the things are inbuilt. Okay. SVD, you don't have to write down the code for SVD. Singular value decomposition, you don't have to write the code. Their built-in functions are there. Just you can functions and you can use it. Okay. Hardly maybe in 10-line coding you can do that. Okay. So nowadays your life is much more simple. What you will do? Ask ChatGPT. Put ChatGPT your question. Okay. The beauty of ChatGPT is to ask question at least. As I said, when you are trying to prove something in mathematics, you know what you are going to prove. Same way, ChatGPT, you should know what are you asking. You can refine your questions. Okay. Coding purpose, like I do rely on ChatGPT. You can use ChatGPT efficiently. Okay. The proof and all, like it will give something which is mostly it is by your common sense. But coding point of view, or if you want to make some presentation, those things, it's good. Yeah. So this is the second application. So two of them of same flavor. It's kind of dimensional. I'm reducing the dimensions using SVD, singular value decomposition. Okay. So I have 10 more minutes. I will just try to briefly tell you something about the last problem, which is the clustering problem. Okay. Next. So the clustering problem, I think most of you may have done a course on graph theory. In terms of graph, one can give another motivation for the clustering problem. So you have a graph, you know bipartite graphs, right? So bipartite graph means you have to bipartition the vertex. You can bipartition the vertex set in two parts such that any edge of the graph will have one end in the one side of the partite set, the other end in the other partite set. Okay. Now we are having a problem. We want to partition our vertex set into k parts. Okay. You can think of something like bipartite. Instead of partitioning into two parts, I want to partition them into k parts. Okay. And I don't have a restriction that the edges should be between the partite sets. It can be in among them also. Inside V1 I may have edges. Inside V2 I may have edges and so on. Okay. So I do have some constraints. Okay. So if I give you something like if I have a graph of 10 vertices, if I ask you to partition the vertex set into three parts, anybody can do, right? You can say first take the first three vertices in one side, the next three vertices in the other side, the last four vertices in the third side. If I had to partition my vertex set into three parts. Okay. The constraints are, so partition means that should cover, the union should cover the entire vertex set. And one restriction is they should be pairwise disjoint. Okay. And the final constraint, which is more interesting. So all the partite should have almost the same cardinality. Okay. So how to almost same cardinality? This means that if you take two different partite sets, the number of elements in both the sets, VA and VJ, they should differ by at most one. Okay. For an example, if I take a graph with the 100 vertices, okay, if I had to partition the graph into 10 parts, okay, if k equal to 10, if I take, then everything should have 10 vertices. Suppose if the graph has 101 vertices, I want a k partition, 10 partition. So in that case, obviously I can't partition into 10 equal parts, right? One part should have at least 11 elements. It's called the pigeonhole principle in combinatorics. Okay, at least one part should have 11 elements. Okay, so that should be the worst case, or that should be the best case. I mean, everything should have 10, and exactly only one partite should have 11 elements. If you have one or two elements, what do you do? Will you go plus 10 plus 10 plus and so on, or 11 plus 11 plus 10 and so on? Okay, that's the meaning of this balance constraint. Okay, it's really simple to explain this. Okay, okay. So now I need one more condition, one more terminology. So between the partings, okay, VA and VJ, you have some number of edges. You count the number of edges. You give a name for it. That's called the W of EAG. Okay, here I'm taking. You don't need to take weighted graph. Just you take simple graph. This W of EAG is just counts the number of edges from VA. Okay, stop. So the problem is, if I give you a graph on, stop. You're not able to hear. Oh, okay. So you have to. So your finding is interesting. Okay, so I have to partition the vertex set into k parts. Okay, subject to the constraint that the sum of the number of edges crossing across the parted sets should be minimum. So if I give you a graph on 100 vertices, by no way like you can ensure any sort of uniqueness of the partition. Okay, 10 vertices I can choose in any number of n number of ways. Okay, of course finitely many. Okay, so I want some sort of minimality. The minimality is just to count the number of crossing edges between VA and VJ, sum all the crossing edges. Okay, I want the number of crossing edges to be a minimum one. Okay, can you find out such a partition? See, after all, we are working with a finite setup. When you want to minimize or maximize certain things, especially this type of crossing edges, everything is over a finite collection. So the minimum or maximum will exist. The question is, again, when you are working in computers, you should ask the question, is it implementable in a easy way? By easy way in the sense that, can I get a polynomial time algorithm to solve the problem? The unfortunate thing here is, next one. So this problem is called, this problem belongs to a complexity class. It's called NP complete problem. So that means that you don't have any easy algorithm to solve this problem. It is not that you don't have, anyone in the world don't have any idea about, is there a like easy problem, easy way of solving this problem? Okay. So how many of you know P versus NP problem? Okay. So if you don't know, go and search it. P versus N problem. This is one of the $1 billion problem. Okay. So if you know about Clay Math Institute, so you can, I think 6 or 7 problems. This is NP, P equal to NP, or this computational complexity problem. It is one of the long-standing open problem in this field. Okay, so we don't know any calculate this kind of balanced multi-partition. Okay, the worst thing is, like, instead of going for k partition, if I ask you just only 2, can you partition your vertex set into 2 parts such that the number of crossing edges are having the minimum? That itself is not solvable in a efficient. Okay. So how to solve it? So I will just tell you how to convert this problem into a linear algebra problem. Okay. The idea or the philosophy is same. I'm going to use the eigenvalues and the eigenvectors. So use the eigenvectors. I'll just explain. Okay. I have around 5 minutes. Just to explain the. I'll stop. Okay. Next. So whenever you have a graph, given a graph, you can always associate a matrix. Okay. So one natural class of matrix is called the adjacency matrix. So when I say a matrix, then I should specify the entries of the matrix. The entries are given in this way. The rows and columns are indexed by the vertex set of the graph. Okay. Both rows and columns, I will index them by set of the graph. And I'm going to keep a 1 if in the underlying graph, the corresponding entries VA and VJ are adjacent. Otherwise, keep a 0. Okay. Next. So this is a simple example. You consider this graph. For this graph, the adjacency matrix is given by this. The first row stands for the first vertex. The second row stands for the second vertex, and so on. Similarly, first column, second column, there stands for the corresponding vertices. The matrix, all the diagonal entries are 0 because I don't have any loop, the edge from the vertex to itself. Okay. And one can associate another matrix is called Laplacian. Next. Full slide. Okay. Next. Yeah. Stop. So the Laplacian matrix is defined in this way. So all of you know what is the degree of a vertex in a graph. You collect all the degrees of the vertices. Okay. Using those vertices to form a matrix is called diagonal degree matrix. As the name says, it's a diagonal matrix. Keep the degrees in the diagonal. Rest of the entries make them 0. Okay. So now you have two matrices. Using this, I define a new matrix. It's called the Laplacian matrix. L of G equal to the diagonal matrix, which I obtained using the degrees, minus the adjacency matrix. Okay. So when you are doing masters or if you are doing PhD, if your area is related to data science or machine learning, if you find the word spectrum, then you will see this matrix in that paper. Okay. This is a kind of, it's a kind of, you know, the notion of dense. So this notion is dense in, if you see the machine learning data science literature related to the spectral techniques. Okay. Okay. Next, we'll see a simple example. So this is how a typical Laplacian matrix looks like. Okay. Off diagonal entries are always non-positive. Diagonal entries are non-negative. Okay. Yeah. Next. Go next one. So this problem, I think in the first I posed the third problem. Given a set of points, how to cluster them into groups. Okay. How people does using spectral techniques, I'll explain. Next. Full. So given a set of n points, I had to convert that n points, or I had to associate a matrix with that n points. Okay. So whenever you have a real life problem in machine learning or data science, if you have some efficient way or nice way to represent that problem in terms of matrix, then you can use your spectral techniques. How to form a matrix? Here, there are many ways to form a matrix. One way is, data points are given to you. I am going to form my matrix, whose rows and columns are indexed by the data. In terms of graphs, if I have to say, you form your graph whose vertices are xi's. I'm going to give weightage between the edge vertices. How do I do that? Between the vertices xi and xj, draw an edge. Okay. Give the weight Sij, whatever similarity measure is given to you. Okay. So from here you have two choices. One is you can work with the complete graph. Okay. Between any two vertices, draw an edge, associate a weight to that, whatever is given to you, similarity measure. Okay. In many real life problems, it can happen that between two vertices, some of the vertices may have similarity which is negligible. In those cases, you don't have to consider those edges. You just discard those. Okay. So now I have a matrix, I have a graph. With this graph, associate your Laplacian. Okay. So after calculating the Laplacian, you do the algorithm. Next. So similarity measure is given to you. The similarity matrix I am forming using the rows and columns are indexed by the data points xi's. Okay. So now I have to cluster the points into k groups. Okay. So n can be like maybe 10 lakh or 1 crore. K can be 1000. I want to group them into 1000 clusters or 100 clusters. Okay. So ideally the clustering, what it will do, when after clustering the points into various groups, the similarity measure between any two elements of the same cluster should be more compared to the similarity between points in the different clusters. That's the idea of clustering. So this is what so form the matrix, form the Laplacian. It's a symmetric matrix. The first course in linear algebra, all of you know symmetric matrices are diagonalizable. You compute the eigenvectors. you just look at first k eigenvectors. In case what I said, like if you have a data points consist of 1 lakh or 10 lakh points, I want 100 clusters, then you consider only first 100 eigenvectors. Okay, form them as a columns. Okay, so now I'm getting a kind of n by 100 matrix. Okay, now I had to do dimensionality reduction. By dimensionality reduction, I mean look at the columns of this matrix. The matrix, how did I form? Initially, the size of the matrix S was n by n, that is maybe 1 lakh by 1 lakh. Now, I associated a new matrix using these eigenvectors of the Laplacian, that is something like 1 lakh by 100. Okay. Now look at the rows. Each row, what is the size of each row? Since I am taking only 100 vectors and forming them as columns, every vector is of size 100, that's all. Now I will apply something called k-means algorithm, which I'm not going to explain. It's really simple that you can read, and k-means algorithm. You just apply k-means algorithm to the row vectors of the newly formed matrix. Okay, for dimension 100 vectors, it works really well. Do the clustering. Next one. Based on the clustering of those 100 dimensional vectors, you get the clustering for your original problem. So this is the entire idea behind the notion of spectral clustering. Okay, so this is quite new. Maybe after 1990s only people developed. Okay, there are various variations of this type of ideas. Variation in the sense that so you can see something I wrote. Spectral clustering. Before that, there is an adjective. Unnormalized spectral clustering. There is something called normalized spectral clustering. Okay, people do. There's something with the normalized Laplacian. Okay, depending upon your problem, you have to choose that. Okay, so if you want to see a Python coding for all these things, just search for these words. You will get like the code for these things. Okay, yeah, this is the mathematical part. The references are. Yes. Okay, this is a summary what I have done so far. So these are all the references. Next one. If you are really interested in knowing about the spectral clustering and the related thing, I would suggest that you read the last one, a tutorial on spectral clustering with your MSc knowledge in linear algebra and graph theory. Okay, you don't need any other to read that paper. Just graph theory and linear algebra is good enough to understand the paper, a tutorial on spectral clustering. It is available in web for free. Okay, Ulrich von Luxemburg, and she has given a course based on this paper, this one. During the COVID time, she is a scientist from Germany. During the COVID time, she has given one full course on machine learning, in which you can find out the spectral clustering and other things. Okay. Yeah, that's all for that. The presentations will be with you. If you are lost or if you didn't get something, you can go through it. I'll be happy to clarify. Okay. So any questions? Anything? Any other application or? You want mic? Okay.
Thank you, Professor, for giving such an intellectual lecture. The theoretical framework explored in these three problems provide a robust foundation for future inquiry. By identifying the edge cases and limitations within these models, we can develop new methodologies that address research gaps in future. Once again, I thank you, sir, for spending your precious time with us. Thank you, sir. The next session will commence at 11:30 a.m. So all the participants and Fatimites kindly assemble inside the Jubilee Hall sharp at 11:30 a.m. Students, we shall now move for a short break to have the refreshments.
The refreshments is right hand side of my hand, okay? The right hand side, and for you it is the left hand side in the Carmel Hall. And Fatimans, you stay there and come back immediately. Other college participants, you too can join.
அதுதான் கரெக்டா சொல்லிருங்க. திருப்பி ஒரு தடவை சொல்லிட்டு அப்படியே ஸ்டாப் பண்ணாம 2 டைம்ஸ். ஓகே, ஐ கம் அகைன் அப்படினு சொல்லிட்டு திருப்பி. ஓகேவா? ஐ கம் அகைன் தி பிரேக் தி ரெஃப்ரெஷ்மென்ட். அடுத்து திருப்பி செஷன் 2 க்கு முன்னாடி நீங்க ரெண்டு பேரும் என்ன பண்ணிருங்க, உள்ள வாங்கங்கறத கூப்பிடாங்க. ஓகேவா? 11:30. ஆமா, 11:30 ஷார்ப்பா. செஷன் 2 க்கு ரெடி பண்ணிருங்க. ஆமா, செஷன் 2. அதே மாதிரி அந்த சார் அவர் என்ன இது பண்றாருங்கிறத இது பண்ணிட்டு சும்மா அதுல அவர் என்ன டாபிக்னு பாரு. சாட் ஜிபிடில போட்டு ஜெனரலா டைம் அந்த மாதிரி
Girls, all the first UG students and all the UG students are asked to come to the green room to collect your refreshments. And PG also.
ஆன்லைன்ல வராங்க.
ஆஃப்லைன்ல அவங்கள மெயில் பண்ணி விட சொல்லுங்க பிபிடிய.
ஆன்லைன்ல பண்றவங்க மட்டும்
ஆஃப்லைன்ல பண்றவங்க அவங்களோட பிபிடியை ட்ரா பண்ணலாம்.
Ma'am. May I have your attention, please? All the participants can send your presentations in Gmail. I'll repeat, kindly send your paper presentations in the Gmail.
த்ரூ ஆன்லைன் போடுமா? Resource person. Resource. Resource. Person.
நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9930092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9930092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9930092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9930092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9930092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கு ஏற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ, மதுரை மேலக்குயில்குடி RTO ஆபீஸ் நேர் எதிரில், அண்ணா யூனிவர்சிட்டி மிக அருகில், 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699. நம்ம மதுரை மாநகரில் புதியதோர் உதயம். நடராஜ் அவென்யூ. மதுரை மேலக்குயில்குடி ஆர்டிஓ ஆபீஸ் நேர் எதிரில் அண்ணா யூனிவர்சிட்டி மிக அருகில் 30 அடி ரோட்டுடன் சுவையான குடிநீர் மற்றும் காற்றோட்டமான வசதியுடன் தனித்தனி பிளாட்ஸ். 1 சென்ட் விலை வெறும் 5.5 லட்சம் மட்டுமே. தனி வீடு வெறும் 22 லட்சம் மட்டுமே. உங்கள் பட்ஜெட்டில் உங்களுக்கேற்ற கனவு இல்லம். தொடர்புக்கு 9943092956 மற்றும் 8667583699.
அந்த கார்னரா?
Students, the program is about to begin, so kindly assemble in the Jubilee Hall. To the kind attention of the students, the program is about to begin, so kindly assemble in the Jubilee Hall.
வெளிய யாராவது இருந்தா உள்ள வர சொல்ல. சாப்பிட்டுதான் வந்தேன்.
Students, the program is about to begin, so kindly assemble in the Jubilee Hall.
இருக்கிறதுனால ஸ்டூடெண்ட்ஸ் யூ கைண்ட்லி மெயின்டைன் சைலன்ஸ்னு சொல்லிடு. மெயின்டைன் சைலன்ஸ், we are about to begin the session. Kindly settle down fast அப்படின்னு சொல்லிட்டே இரு எதையாவது. இந்த வந்துட்டார் பாருங்க.
Students, as we are going through virtual mode, so kindly maintain silence. Students, please be seated on your respective places.
ஃபேனை கொஞ்சம் திருப்பி வைக்கணும். முடி பறக்குது வைக்கிறப்போ.
Students, those who are standing outside the Jubilee Hall, the program is about to begin.
கேட்கல. அங்க ஏதாவது என்கேஜ் பண்ணணும். எதுக்குடா வாலண்டியர்ஸ் அரேஞ்ச் பண்றது? யாருமே வரல. தான் அனௌன்ஸ் பண்ணனும். சொல்லுங்க ஸ்டூடண்ட்ஸ்.
Students, the program is about to begin, so kindly assemble in Jubilee Hall. I repeat once again, the program is about to begin, so kindly assemble in Jubilee Hall. Students from the other colleges are asked to come to the Jubilee Hall as we are going to begin the program.
வந்து ஜாயின் பண்ணிக்கிட்டோம். டசன்ட் மேட்டர். நீங்க அவங்களுக்காக வெயிட் பண்ண மாட்டாங்க. அவங்க இப்பதான் வாஷ்ரூம் பார்த்து போயிட்டு வரட்டும். நம்ம ஸ்டார்ட் பண்ணிக்கலாம்னா ஒரு சைடு மைக்கு சவுண்டே கேட்கல.
அதாவது அமைதியா இருக்கணும்னு சொல்ல. அப்ப நான் go through going to have this session through virtual mode. Students kindly maintain pin drop silence in சொல்லுங்க. ஒரே நிமிஷம் நான் கூப்பிடுறேன். சரி வாங்க வாங்க. ஜூப்ளி ஹால் கேட்பாங்க. ஆமா as we are going to have the session through virtual mode. Dear students kindly maintain pin drop silence. Kindly maintain pin drop silence Pin drop silence. I'll come. Silence now. Okay. இதை சொல்லிட்டு ஆரம்பிங்க. சொல்லிட்டு ஸ்டார்ட்
Students, as we are going to have the session through virtual mode, you are asked to kindly maintain pin drop silence. I repeat, as we are going to have the session through virtual mode, students kindly maintain pin drop silence. We shall now proceed to session 2 of the ICMISF 2026. As we look for future research avenues, understanding these complexities is vital for our collective growth to help us to navigate these complexities. We are honored to connect through virtual platform with our distinguished professor, Dr. Prabhu Nadarajan, Assistant Professor, Mathematics Section, College of Computing and Information Science, Sultanate, Oman. While miles may separate for physical location, we are incredibly fortunate to be connected through the virtual platform today, sir. We begin the lecture. I invite Dr. V. Vanitha, Assistant Professor, Department of Mathematics, to welcome our resource person.
Education is not the learning of facts, but the training of the mind to think. Albert Einstein. Respected dignitaries, on and off the dais, esteemed academicians, distinguished researchers, distinguished researchers, honored guests, participants present here in our college and those joining us virtually from across the globe.
அவருக்கு அவங்க கேட்கலையா இந்த வந்து இங்க அதுல போன்ல வேணா ஆன் போன்ல வீட்டை ஆன் பண்ணி வச்சுட்டோம்னா இதுவா இதுலன்னா அவருக்கு கேட்குமா அவருக்கு கேட்கணுமா அங்க கேட்கணும் கேட்கணுமா அவ்வளவு சரி
We shall now proceed to session 2 of the ICMISF 2026. As we look for future research avenues, understanding these complexities is vital for our collective growth to help us navigate these complexities. We are honored to connect through virtual platform with our distinguished professor, Dr. Prabhu Nadarajan, Assistant Professor, Mathematics Section, College of Computing and Information Science, Sultanate, Oman. Before we begin the lecture, I invite Dr. V. Vanitha, Assistant Professor, Department of Mathematics, to welcome our resource person.
Education is not the learning of facts, but the training of the mind to think. Albert Einstein quotes, respected dignitaries on and off the dais, esteemed academicians, distinguished researchers, honored guests, participants present here in our college auditorium, and those joining us virtually from across the globe, a very warm and pleasant morning to you all. It is with immense pride and heartfelt joy that I rise today to extend a gracious welcome to our distinguished resource person for this international conference, Dr. N. Prabhu. Though Dr. Prabhu is joining us online from the Sultanate of Oman, his academic presence and intellectual influence transcend geographical boundaries. Today's hybrid platform, blending offline participation in this auditorium with vibrant online engagement, reflects the evolving spirit of global academia, where knowledge travels seamlessly beyond borders and time zones. Dr. N. Prabhu currently serves as Assistant Professor in Mathematics at the College of Computing and Information Science, University of Technology and Applied Sciences, AI, Musanna, Sultanate of Oman. He earned his PhD in Geomatics Engineering from the prestigious Indian Institute of Technology, Roorkee, along with an MPhil in Mathematics, demonstrating a rare and powerful combination of mathematical depth and technological expertise. As the famous mathematician Galileo once said, mathematics is the language with which God has written the universe. Dr. Prabhu's career beautifully exemplifies this truth. His research journey translates mathematical theory into meaningful real-world applications, particularly in hyperspectral image processing, remote sensing, artificial intelligence, renewable energy mapping, optimization, and data mining techniques. With over 2 decades of academic and research excellence across India and Oman, Dr. Prabhu has consistently demonstrated scholarly rigor and innovation. His pioneering contributions in wind and solar energy mapping using artificial intelligence and advanced data mining techniques have earned him prestigious recognitions, including the AI Incentive Award for 2020-25 and the Best Research Paper Award 2025. His publications in reputed international journals and IEEE conferences stand as strong testimony to his dedication to impactful research. He also served as principal investigator for funded research projects integrating IoT and agrivoltaics mapping in renewable energy systems. In a world increasingly concerned with sustainability and climate responsibility, his work powerfully demonstrates how mathematics serves as the backbone of sustainable technological advancement. Pure mathematics is in its way the poetry of logical ideas, said Albert Einstein. Dr. Prabhu's academic journey reflects this poetic harmony between logic, innovation, and application. His invited talks and lectures on machine learning applications in mathematics, applications of remote sensing in renewable energy, and feature reduction techniques in hyperspectral imaging have inspired scholars and students alike. Today's session is particularly meaningful. While we gather physically within this auditorium, scholars and presenters are connected virtually from different regions. This hybrid model symbolizes inclusivity, collaboration, and shared pursuit of knowledge. It reminds us that academic dialogue is no longer confined by walls. It thrives through the connection. Sir, even though you are addressing us through a digital interface, your expertise, experience, and insights will undoubtedly resonate deeply within this hall and across every virtual screen connected to this conference. On behalf of the organizing committee, the faculty, researchers and students, both present here and attending online, I extend our warm, most respectful and heartfelt welcome to you, sir. We are truly honored by your presence and eagerly look forward to your enlightening address. So let us unite both offline and online in extending a grand and enthusiastic welcome to Dr. N. Prabhu. Thank you. Welcome, sir.
Welcome, sir. The stage is yours.
The Reverend Sister Ignatius Mary and Reverend Dr. Sister M. Fatima Mary, the Principal, Fatima College. This is this is she. First participants, the research scholars, students. And also I like to extend my thanks to my ABC, Assistant Vice Chancellor, Dr. Nasser Salem Al-Bimani, and Assistant Deputy Vice Chancellor, Dr. Nihad, my Head of Department, Iman, and my Head of Unit, Dr. Astin, for giving a wonderful platform. And also I have to thank the technology also, because the year 2017. So, let me wait for a few minutes. Just I got a message from there. Yes. Now am I audible? Let me talk.
Yes, sir.
Okay, fine. Okay, fine, good. Okay, so anyway, so the year 2017, I have given a presentation in Fatima College, the topic applied mathematics. Okay, so from that and now, I found a huge difference. Okay, so that time also I was working in the same place, Oman. Okay, but now I am giving you presentation through online mode, especially because of the in between something happened like the pandemic days. Okay, so we started to use something online mode. Okay, so that helps in transferring the informations now. Okay, so anyway, so whenever anything so comes, any any hurdle comes, okay, we have to go further for that one. So that itself is the topic name. Today's mathematical innovations for a sustainable future. So our future, it goes on further. Okay, so for that one, there we are using mathematics. Okay, so that we are going to discuss. Already the previous presentation I have listened to it by Dr. Rajesh Khanna. Few minutes I have listened to it through YouTube. Okay, so and really very wonderful presentation of that one. Okay, so mine is also almost related to that topic, image processing, in a different perspective. Okay, so you can able to understand. So how clearly he explained, and of course many of my work he has done, I can tell that one also. Okay, anyway, so my presentation is about mathematical innovations in water storage management. I'm searching something to minimize this. Okay. Okay, so mathematical innovations in water storage management. So I am Dr. Prabhu Natarajan, Assistant Professor Mathematics Section in College of Computing and Information Science. It is part of University of Technology and Applied Sciences, Al Musanna. It is in Sultanate of Oman. The outline of my presentation, introduction about the future. What are all the things we want to focus in the future? In the later side, I will explain. then the mathematics behind water storage system. Then a few words about remote sensing, renewable energy, and water storage management. About the project, the research grant project one capture. So what it is required, anyone, if you means immediately we will tell food and water, food, water and air. These are the essential things for our life. Okay, so but now, so compared to the earlier days, 100 years back, and now we want to take care of each and everything. So not to waste food or not to waste water, even air is polluted. Delhi is suffering a lot because of pollution. Okay, so because of industrial pollution, not just because of population, because of industrial pollution. Okay, so for all these things needs to be managed, not just to grow crops and transport and take food, not like that one. It is planned one. We have to plan how much food is required, how much food can be produced and all. Okay, it can be done in an optimization way. It is not like one type of crop is produced enormous. Okay, so then also, so that is the reason. So for food production, for storing of water and air and all industrial needs, everything needs to be planned and produced. And data science and climatic modeling. So mainly for climatic modeling, when there is a rain, when there is a disaster, earthquake and all. So all these data needs to be stored. There are some data which we can store for a few days. There are some data required for years, decades. Okay. For example, earthquake related data, just 2 years data is not sufficient. We need for 100 years data, maybe more than that also, for climatic modeling. So what is the temperature yesterday? For example, if I tell temperature, just assume any one place and what particular, okay, so that day, that temperature, with that one alone, can we tell what is today's temperature means? We cannot. Okay, so for that one, it requires even a huge amount of data, 1 year data or 5 years data. Okay, so how a cyclone behaves, how we will come to know, not just calculation, but also from the data. From the data only we can, from the data we have to create models to predict how it goes on. Then renewable energy system. So nowadays the fuel what we are using, these petrol, crude oil and all. Okay, so they are limited. Maybe few millions of billions of barrels may be available, but the way how much we are consuming will drain very fast. So have to go for other source of energy, and already we have started like electric power. Okay, so in that case, produce more amount of energy. So for that one solution is renewable energy system. Okay, so I will then economy. Population. Properly. Okay, balance. The smart city and the urban planning. Okay, so there are 3 C's organized city. Okay, so smart cities does not mean just only with Wi-Fi and all. Okay, so like a zero waste. So how to reduce the pollution? All these things are taken into the account. Okay, for all these things, we need to tackle. So in this presentation, so the resources for the future like food, water, air. Okay, so this one. But the main concentration it is about the water storage system. Even though food, water, air, materials and so on, only thing we are concentrating on water. In that water, there are so many ways we can save, store the water, not save the water, so store the water. For example, tanks, overhead tanks, rainwater harvesting, natural water, dam or reservoir. Okay, so for this, so the idea of renewable energy is important. So I will explain you about renewable energy also, especially just 1 or 2, depends upon the time. Okay, then remote sensing technology, how it is helpful and what mathematics used here, so that we can the renewable energy, from renewable energy, how water is stored. So this is the way how we are going to go. So from water, in remote sensing, the idea of only optical remote sensing will be dealt with. Then in renewable energy, solar and wind, I will explain. Anyone, depends upon the time. Then water storage system. So the other tanks, like tanks, overhead tanks at our home, or for a city, okay, it's not that, only for a dam or reservoir. Okay, about this one, we are going to, because we have done a project related to this one. For this one, yes, it is to store the data. Okay, so we want to store the data. So earlier I said we need to collect a lot of data, depends upon the process. Sometimes we store the data and okay, after finished, that data is not required, only the output is enough. But for something, we have to keep it for years. So the way how we store the data in the paper form, store the data in the digital form, anything, it needs to be a perfect. So that, okay, so later on when we want to retrieve it for using, it can be, without confusion, we can use it. Another one, compressed. So some data can be compressed, every data can be compressed. Some data we have to compress, some data we no need to. Okay, so for example, data for an image we have, I have a very simple example. We are taking photograph of a particular thing, 5 photographs we are taking. Okay, so 5 photographs of a tree we are taking. Okay, even though there are 5 photographs, we don't want 5, we need only 1. So remaining 4 can be deleted. Simply we can delete, just we can analyze personally or manually we can analyze and we can delete the remaining 4. Okay, so it is all. It is also compression, it is also data reduction. Okay, the other is track here. Every 1 hour, our data temperature. That's all. Every 1 hour take temperature. That means one day we are getting 24 data. So that means it is a 24 element array vector. Okay. The same way for 12 days we have 12 vectors are there. Sometimes what will happen, 4th and 7th may have the exactly same vector. In that case, can we delete? Means no. Same data we have, but we should not delete. So the place where we want to compress, we can compress there. But by compressing, we should not lose the information. That is the point. Okay. So when to compress, we want to know, and what to compress. Then the data should be kept securely. Any type of data, the messages what we are sending also, it is a data, and they also can. Anyway, now we will go directly to the where we will use these techniques. Like in creating algorithms. Without mathematics, we cannot. Then for machine learning also algorithms, pattern recognition. Then Internet of Things will connect materials with the internet, so that we can access from a remote place. And artificial intelligence. Nowadays, it is completely artificial intelligence. Those days, for any topic, we will search Google. After that, now it comes ChatGPT. Okay, so these are the things which are maybe use it for studying, we'll use it for the positive direction. Okay, so where till now we have used mathematics for water storage. Here is the water tank. Immediately when we say this one, in school days we will study what is the shape of a water tank. Okay, don't see the height, see only the water storing area. Mainly we will talk about it is a cylinder. So cylinder means what is the height of the cylinder, what is the radius of the cylinder, and we can able to find the volume. But many drawbacks, practically when it comes, very much drawback comes. What is the drawback? For example, the same logic. So during school days, when we study about, what is this one called? Shape of a rectangle. Immediately we will tell the table is shape of a rectangle. But the rectangle is not having sharp edges. Okay, it is not completely like a rectangle. The area, if we calculate, there is some small error. So such type of error, not mistake, error, such types of errors will be there in every place and needs to be managed. Okay, so geometry and mensuration we have used for finding the volume. Okay, so here it looks like it is easy for us to calculate the volume, but the real project comes with a little different idea. Okay, so to find the surface area of the water tank, comparing capacities and all. Algebra, where we are using algebra, mainly for filling the water tank. Okay, so how much time it will take to fill, how much time it will take to empty and all. Then arithmetic, like whether it is cubic meter, millimeter, TMC for dam and reservoirs and all. Okay, so these are the mathematics we are using and trigonometry. And here, this water tank here, what I am showing to you, this is in India we are using. And here in Oman, this is one type of water tank. Okay, it depends upon the population. Here it is a thin population. Okay, so this type of tanks are being used. Okay. So here also same logic. Cone, instead of cylinder, here it is a maybe a truncated cone or something. Okay. So trigonometry can be used to find how much is the depth of the water level, and statistics. So how much water is required every day, how much water is being used. When water is used, then have to it will affect in the drainage system also. Okay, so with the help of bar graphs, pie chart, and all, the water consumption can be compared. Then in calculus, so how much water is here? I am in Oman. For me, the only source water comes only from here. The water comes only from here. For all the needs, we will use here. Only for farmland, they will have their own like a borewell or other source of water. For us, we have only this source of water. Any day, if I open my pipe, okay, water will come, because any day it will be, whenever from my water tank water is reducing, immediately water will be filled. The same way, the peak time, most probably in the morning time, the whole, most of the time. So everyone will open the water. So what will happen? The water will reduce at our home. At the same time, immediately it will fill, automatic system. Okay, for this one, how much pressure should be given from the water here? Because less pressure, water will not come to the home. More pressure, the pipes will burst. Okay, so an optimum range needs to be calculated here. Then coordinate geometry. So we are using this one for mainly for graphs and modeling, tank filling and draining. Then real life application like rainwater harvesting calculations, storage needed for a household, how much we need. At our places, usually we will not pay anything for water. We are paying only for the electricity bill for pumping the water. Okay, so for those things, that's what we will do. We will use unlimited. Okay, so we have to manage this one. Means we need to analyze how much it is useful for one person. Even every day it may be different, but it is under a certain boundary. Okay, so it can be analyzed. Then cost analysis of water storage systems. So I will share you another presentation. In that one, I will show you renewable energy. Okay, remote sensing. First I will open, then I will share, because when I share the screen, entire screen, it is that the fractal geometry is coming. Yes. Okay. Now, can you see the screen? Remote sensing. Anyone, can you send me the message? Now it is okay. Remote sensing. The slide which I have shared to you is remote sensing. Can you able to see this one? Yes, yes. Students, those who are sitting in the front, can you raise your hand if you see the screen remote sensing? Because I can, yes, very good. Thank you for, yes, now. Okay, now. So here remote sensing. So I said to you where remote sensing is used for water storage, renewable energy, remote sensing. Okay. So I said to you in the year 2017 when I have presented for applied mathematics, the same topic, remote sensing. In that same topic, I have line by line explained how image is formed. Okay, because here due to time constraint, because I am going to focus about other two major areas. Here I will just explain about few words about remote sensing and images. Okay, so remote sensing is the art, science and technology. It's a very beautiful idea. Because when we are studying, for example, we have studied physics. Physics is science, we will tell. Or English, it is an art. But here this remote sensing is art, science as well as technology. of acquiring information about the Earth's surface without making physical contact. That means we can take photograph just by taking a photo itself is remote sensing. Okay, but about Earth we are taking it is directly remote sensing. Okay. So there are types of remote sensing: optical remote sensing, thermal and microwave remote sensing. I am not going to deal about 2 and 3, thermal and microwave, only optical. Optical means what we are seeing. What we are seeing. So we are seeing something. So in my opposite there is a cupboard brown color. It is brown. So how do I know it is brown color? It is optical. In thermal remote sensing, the color is not known. In microwave, microwave means how the bat, how it will see this one. Okay, so it will not know what is the color. Okay, so only optical we are seeing. So it is in the visible range 0.4 micrometer to 0.7 micrometer. Okay, so it is this is our visible range. Okay, so if any wavelength less than 0.4, greater than 0.7, it is there. We cannot see. One simple example, what I am talking, the sound you can hear, but you cannot see the sound. Okay, because the wavelength is different. Okay, in this simple way you can understand. So the visible, what we are seeing, it is same visible range. The photograph, the camera, what we are having, the mobile phone camera or any other camera, what we are having, it can take photograph only in this region. Apart from that, there are other regions like near infrared, short wave infrared, midwave infrared, and so on. Okay, but there are some cameras, or they are called as sensors, can able to take from these wavelengths also, and they are useful in identification of some materials that we are going to see here. Okay, so there are so many types of resolutions. Okay, so spatial resolution. So before Dr. Rajesh Kanan, he explained about this one grayscale image. Any band, red or blue or any one band that is there, is called black and white image. Actually, it is grayscale image, but we will call it as usually black and white photo. But it is spectral. Spatial resolution, it depends upon how many details available in one pixel. Okay, so the image processing, usual image processing, there is a difference between that one and here. Okay, so let me write something here. Okay, so we have an image. Here in remote sensing, when I tell image, the same 5 cross 10 I will take, 5 rows, 10 columns and so on. Okay, so let me take only few. Okay, so 5 cross 10, 5 cross 10. This is 1 pixel. This is 1 pixel. Okay, but how much quantity, how much information is stored in this pixel? In each of the pixels, everything is a square. It takes from the same place. So this is a square. This is a square. The area of this square in the ground and the area of this square in the ground need not be same, but the pixel size is same. The pixel size is same. Okay. So this pixel, how much? For example, this shows, for example, a satellite image. One satellite image. We have plenty of satellites. Even I can tell how many buses are running in Madurai. More than that, the number of satellites are there on the sky. Okay. So, for example, here, what is this one called? 1 meter resolution. This is 1 meter. Here also 1 meter. Usually, the resolution will be measured in terms of meter. Just 1 meter. The meaning for 1 meter is 1 meter in all the sides. It is a square. So, it is 1 square meter area is covered in that 1 pixel. Information is covered in this pixel. Okay. Please note that the satellites are kept minimum 700 kilometer above Earth's surface. Minimum. And up to 36,000 kilometer above the Earth. That depends upon our need. We can able to place it there. Okay. Another one, there are some aircrafts. The aircrafts will fly maybe 5 kilometer, 10 kilometer, or even less also. Okay. So depends upon that, the resolution vary. Usually 1 meter resolution. In that 1 meter, just assume that one. What will happen in 1 meter? There may be a road crossing like this one. Okay. This is road. This is road. Okay. In this pixel, a part of is covered by road. The other place there is a greenery area. The other place there is a sand. In 1 square meter area, I will not tell 1 square meter next time, 1 meter. Okay, in 1 meter, maybe 2 or 3 or 4 or many classes, there is a possibility for mixture. Because there are some images, they have the pixel 1 kilometer. 1 kilometer. So inside 1 kilometer, what are all there? What are all there? So for example, the place where you are there in the auditorium, around that one, what are all the areas you can tell? You can say buildings, you can see trees. If I tell trees, there are variety of trees. Then you have, what is this one called? Railway track, you have roads, you have what is this one? A sports complex. That sports complex, from the above you see it is different. The auditorium and sports complex looks like different because it is maybe different material it is there. Okay. So according to that one, in this 1 kilometer, what is present, how much percentage is present wants to be calculated. It is spatial resolution. Spectral resolution, the same 5 cross 10, the same 5 cross 10. Okay, this is one image, 5 cross 10. It is red band. But if I take only red band, it is only gives you black and white image. RGB, this is green. Okay, so how much pixel here? 5 cross 10. So same 5 cross 10 here. Same 5 cross 10 here. When 3 colors are mixed, RGB, same 5 cross 10. Now, when you combine these 3, it will give a color image. Actually, everything is processed in our mobile phone itself. Okay, when we take photo, it is a 3-dimension matrix, 3-dimension matrix. Okay, so this R is one dimension, G is another dimension, B is another dimension. Here there are 2 dimensions. Okay, so X and Y if you tell. So, for example, here, if I tell about a pixel, it takes about water. Then every such place, say every the first column element shows the same place. Details about the same place. The numbers will be different, depends upon the frequency. So, in any satellite image, how many such bands? RGB is just example. In our camera, only 3 bands. But in multispectral, I think the next slide I have. Yes. But in multispectral, if you see multispectral, here the blue is 1 band, green 1 band, red 1 band, then infrared some 7 to 10 bands. The same thing if it is hyperspectral, the blue alone there are nearly 10 bands, nearly 10 bands. Green there are 10 bands, so altogether more than 200 bands are there. 200 bands. Just imagine how much huge data. How much huge data. What I am telling, 5 into 10 into 200. It is a number big. Now, the next problem, radiometric resolution. Radiometric resolution means, again, it is not important here. But for example, an image usually we will tell it is 255, 200, 2 power 8. Okay, so 8-bit image, 2 power 8. But actually here, we are spending a lot of amount sending satellite there. So we will try to take very high, very fine resolution data. That means it is not just 2 power 8, 2 power 16. Just later on, just calculate this number. Just calculate this number. What is this number? Convert this one into MB. How much it will come? Okay, I take a very simple image 5 cross 10, not 100, 5 cross 10 into 100 into 2 power 16. Each number is 2 power 16. 2 power 16 means 16-bit data. Okay, how much it will come? Okay, but reality, one hyperspectral image around 1000 cross 500. So 1000 cross 500 cross 200, just 200 bands. 200 is less number into 2 power 16. Okay, to store this data, it is more than maybe 3 or 4 GB. 4 GB it will come. So after then, when we do processing, it will take. So the idea of compression and all, we use a lot of mathematics to do compression. Now here is the pixel. What I said, there are 4 classes mixed, but a pixel will not be of different colors like this one. All together, it will produce only 1 color. That means if you have watercolor, okay, check this one. 35% of blue, 5% of yellow, 30% of red, 30% of green. Mix it together. You will get 1 color. That is this color. Here we will calculate with the help of numbers. This one says each one, every object, what we are seeing, what we are having, will reflect in a different manner. For example, vegetation. Okay, this is the. So here, what it means. Okay, the next slide I think I have. Here. If you see here, one wavelength I have taken. So I said, see, if you see, the color is not changed. So, for example, if you see, I said earlier, so many dimensions. So here, if you see blue, green, red, inside blue, if I divide, all these things almost the same. This one, almost the same. That means neighboring bands are highly correlated. Here I have shown you about bands. This is the blue band. Inside blue, there are maybe 10 bands. Blue one, B1 and B2 and B3 almost looks like same. B1 to B10 may be difference, but B1 to B1 almost the same. But almost the same, I cannot tell that. How can I compare almost the same? Not just by numbers, because I have 1000 cross 500 pixels. One pixel plus one, another pixel minus one. When you take average, it is 0. I will tell both are same. But it is a wrong calculation. So there are some other techniques to find band 1 and band 2. How much? It means the idea of correlation comes. Okay, neighboring bands are highly correlated. Okay, in other images in black and white, what usually we will study, neighboring pixels are highly correlated. Pixel 1 and pixel 2, 1, 1 and 1, 2 are highly correlated. Okay, not much sudden difference will be there. But here, neighboring bands are highly correlated. So, no need to take band 1 and band 2. We will extract that one and we will take a limited one because already we have a huge amount of data. We have to reduce it. Now, let me go fast. Here, now this idea shows to you what it is. See here, this is band 1. For example, this is your red band. No, not red band. It starts from actually blue. Anyway, so this is your band 1. This is band 2. This is band 3. Band 250, 260 I will take. See here, this 1 pixel it is showing. 1 pixel it is showing. Okay, so this one, which area in the ground it is taken, the same area in another band. Usually here number 35 means here maybe 36. The next one 37. Next one maybe again 35. Okay, the same way, all the numbers. Okay, by this way, the hyperspectral images are interpreted. Okay, so here it is. Hyperspectral imaging consisting of occurring a scene with numerous narrow contiguous spectral bands. So we are taking information from the idea of slit. Okay, the sensor slit will be placed. How much continuously it will be placed, so that we will not lose data in each of the wavelength intervals. These are the ways how to represent. Okay, so there are some ways which are familiar for us. For example, here, just assume there are 2 bands, band 1 and band 2. Red, blue, green, I said so many, but only just 2 bands we have. This is red band, this is blue band. So RG, better G, RGB. It is a 3 dimension. But I will show you example here only 2 dimension. In red it is 50 and green it is, for example, 14. So just plot 50 cross 14. That's all. Very simple. But what about for 3 dimension? You want to draw. What about for 4 dimension, 5 dimension, 6 dimension? Difficult to draw using feature space. Okay. Here, the image space. The image shows so many things. By looking at it, you can tell what is this one. I hope so you can tell what is this one. Okay, it's an aircraft. This is an aircraft. Okay, so in this case, a feature space will not be helpful here. For this one, the spectral space is not helpful. So the idea is it needs to be deal with all the 3. Some information we will take from spectral space, some ideas we will take from feature space, some information from image space. What is spectral space? Each object gives reflect. Each object reflect different. Okay, in different wavelengths. Okay, so the same thing I have shown you here. Here I have shown to you. Okay, so how vegetation. For example, here I have shown you vegetation. This is vegetation means a plant. Okay, so I will take another color, red color. Okay, for example, the green color, what you are saying is coconut tree. Okay, how another plant looks like, the pattern is almost same like this one. Okay, the pattern is almost same like this one. Okay, so it will not exactly coincide. It will be something like this one. Okay, so how soil will be, another soil almost similar to this one. Okay, anyway. Now directly I go for feature reduction and all. I think no time to explain all this. Directly I will go to feature, this one. So we have to do feature reduction. Okay, assume that we have done feature reduction. Classification. What is the meaning for classification? We got an image. Okay, in that image, what are all the classes available? Classes means I said to you, road is a class, building is a class. When we take a photo of a known place, we can tell this is road, this is tree, this is building. Okay, but imagine in a forest, we take a photo. Okay, so everything plants, everything trees, but a particular type of tree, how much area it is covered. Okay, so we want to know. For example, we are having so many, some weeds, some unwanted plants are there. Okay, so they will drain the water system at all, entire water system. Okay, so ground level water it is sucking completely. So we want to cut them. Where is it available? Okay, so nearby our place we can see, we can travel, we can see that there are places deep in forest we cannot go and see with the help of remote sensing images, with the help of hyperspectral images, not other images like multispectral. Multispectral only 7 bands like what we are seeing, the RGB cannot be helpful because it will show only a color. It is a plant, it will show. It will not show what is that plant. Okay, for that one, we can able to do classification. There are mainly 2 types of classification. One is per pixel, another is subpixel. Per pixel means in that pixel, what is the major object cover? It will measure it as that class. For example, 70% building, remaining 30% road is there means it is converted as, it is considered as building. That is per pixel. The next one is subpixel. Subpixel means we can able to find that. So there is 70% of building, 30% of road is there. With some error. For example, instead of 70% may come 60%. Okay, so that error will come. Okay, without error, very difficult. Efficiency is very less only. So let's know it. Okay, so why we need to go for feature reduction? Just a word I said. Okay, not much inside this. There are so many concepts everywhere. We completely use mathematics. Every time when the data is different, the idea of mathematics also different. Either the mathematics what we have already studied will be used for a new idea or a new mathematics developed for an existing data. Okay, any one will be done. So I think the morning session he explained about singular value decomposition. So the same way here, principal component analysis, all these are decomposition techniques. That means breakdown. Break the given data, break the given matrix and then rearrange in the form which we need. Okay, so no need of this. Per pixel classification. Here is the image. Okay, so like a matrix or like a table form it is given. And they are filled by numbers. 1 means it is one type of class, 2 means another type of class, 7 another type, 9 another type. Now what are all the colors these numbers are? It is filled by this. This is per pixel after classification. After classification. But really, if you see here, all these are boxes, so rectilinear. But real image, they are like curvilinear. Okay, so that comes as error. Definitely, without error, we cannot be able to. So, or we want to do what we want to do. We want to find subpixel. We want to find exactly where it is. Okay, so it depends upon our need. We can do those things. So, how to do this one classification? Here is one type of classification in 2 dimension. It is explained. The red color is one class, blue and the black, all these are, so there are 3 classes. Just you put a parallel paper. These are, what is this one called? Training data. Training data. That means that the image is having, I said 50 cross 100 pixels are there. Okay, each pixel belongs to which class? Red or blue or black. To identify this one, take sample, random sample. So for this one, random sampling technique also useful to take data for testing, data for training. This is training. Training comes first. Okay, what it is training? Take a sample data, and we will enclose this one inside a box. Okay, so now any vector, the remaining 50 cross 100 pixels, 50 cross 100 vectors, pixels. Which one comes into this box considered as class red? Which one comes into this one considered as class blue, black, and so on. Okay, but there are so many drawbacks. here is the drawback. Figure two pixels are two classes are mixed. So the one which is in the center, this one can be considered as blue or black, we don't know. Okay, so we have to personally investigate this one. Okay. Now, directly I go to, this is a support vector machine. One important idea, a simple idea, but very powerful. Simple but powerful. Okay, so there are two classes. Here there is a line which it is drawn. Okay, so so this can be segregate this one as two different classes. Okay, please note that these are training pixels. These are training pixels. That means randomly I take, for example, 20 pixels I have taken. Okay, so this line when I have drawn, okay, it is dividing this one into two. But randomly if I take another set, another pixel may be here. We are very close to this line. Okay, here. Very close. So there are so many lines can be drawn. Among these, which one is the optimum one? Which one is of the maximum distance from both? Sometimes what will happen, we draw a line here, which is the maximum distance from red, but it will be close to green. It should not be. So we have to find so many lines can be drawn. If you can able to draw two lines, then infinity lines can be drawn. So among these lines, which one is optimum? Can be found out. Okay, see, if you see here, there are so many pixels. So here, this green and blue are same. Both are, okay. But the line is decided with the help of only these two blue. Over this green color. Okay, because other pixel vectors no need to worry. Okay, that is the advantage of support vectors. No need to have more number of training data. With few amount, we can able to find the training. One pixel. Option to take T. So according to that one, the numbers will change. From this one, this is the input, and the output is classes. How many classes? Here it is mentioned only 4 classes: water, vegetation, wetland, soil. That means in the first pixel vector, how much? First every pixel vector, okay, 4 numbers will come. That means how much percentage? Water. This is for what? This is right. So how? Okay, so one that is what it is, the way how we model, very simple, and the one which we have studied. So we have studied the solving system of linear equations. Okay. So simple one question I will ask you: if there are 3 equations I give you and 3 unknowns, can you solve? This is the question. If you solve, that means you will get solution. Okay, how many solutions will you get? Okay, even though this is the question, I did not have said about the nature of the equations. Okay, so whether they are, what about the linear combination? Nothing I have said. Okay, so because here this is the practical implementation. Any type of equation may come. Okay, but for example, when I said to you 3 equations, all 3 equations are same, means then how we can solve it? Okay, so we so like that. So here, how it is? This is same linear equation. So when this solving of linear equations comes, just Google it. Okay, so it is more than 2000 years ago. More than 2000 years, it already there, but still we are using because of its robust, it's strong. Okay. So X is the, what is this one? X is the, M is the end member spectra. That means the training data. F is the fraction abundance. That means in one pixel, how much value. X is from the matrix. The pixel vectors. Okay. So usually any mathematics problem we study X is unknown. But here it is not like that one. X is known. Okay. F is unknown. That means find F. What is E error? I said there's some noise will be there and all. Okay. Just assume now without error. How will you calculate F? So for this one, just one more point I will tell you. This X, assume that it is, I said it is same like this image. Here we have image. For example, it is having 10 bands, and I have 5 classes. 10 bands, 5 classes. 10 components, 5 classes. Okay, so 10 bands I said. So this is nothing but 10 cross 1. It is a vector. So this is equal to what is M, the end member spectra. So each class, how it will behave in each band. So it is 10 cross 5. Okay, so pixel, it is a matrix. Now fractional abundance, it is nothing but pi cross 1, because there are 5 classes. Okay, so I minimize the error and solve this equation. Okay, so it is already solved. So for our work, we have directly taken that one. Okay, so the method of least squares used to find this one. Here it is the F. Okay, so M is the matrix, so M transpose we can find, inverse we can find, and here it is pooled matrix for its inverse we can find. Just to substitute here, we will get answer actually. But the solution, how to find, it is the mathematics part. Okay, so the idea is we can able to separate how much percentage is available in each of the pixels. We can able to find, and how we can find this by mathematics ideas. Okay, so here, no. Okay, so here is another model. I don't wish to go into this one. Better I will go to another one. Directly I will take the next one. Okay. Wait. Renewable energy and water storage. Let me share this one. Can you able to see this one? Same way. So anyone, if you can able to see the slide, what I have written, renewable energy and water storage system I have written. If you can able to see, can you please raise your hand? Those who are sitting in the front. Yeah, yes, thank you very much. Now I will put full screen. Renewable energy and water storage system. Okay, so where the remote sensing is useful. Okay, so the mathematics is used for reduction, maybe storage of data. What is this one? Processing of data, reduction of data, classification of a place. Okay, so for example, we have a place for all these things. Remote sensing it is used. Now, where remote sensing is used for renewable energy, we will see. First, renewable energy. It is an energy that comes. It is abundant. It cannot run out. Okay, so the main thing actually, even though it is not run out, maybe some 100 years back, even petrol, diesel also not run out. But the way how much fast we are consuming, very fast it will drain. Okay, but so the main concept is usually have a low or zero carbon footprint. That means green energy. Okay, so it will not give us what is this one called carbon. Carbon will be less. Okay, wastage. Pollution free. Okay, so there are few renewable energies I will show to you. One is the wind energy. Okay, so in India we can, especially in Tamil Nadu, we might have seen a large amount of this one. Then solar powers. Okay, so even a small device can have this one. So this the idea we know. Okay, and bioenergy, hydroelectric, okay, and tidal energy and so on. Okay, so there are something which are possible in Oman. So I will. So that is a reason for our project. We have taken this one. The project which we have finished. It is design and prototype development of renewable energy for irrigation, hydropower generation using IoT, so that we can control everything from our office. Okay, and agrivoltaics mapping in Oman. So I am the principal investigator for this one, and we have finished 1 year back, and the cost is around 15,000 riyal for this. No, $15,000 for this. Okay. The areas what included renewable energies, mathematics we have used, remote sensing, classification, elevation measurement, volume calculation. So here again the innovative method of volume calculation comes. IT, data mining technology, IoT and AI we have used. Here is an image. Can you guess what it could be? Okay. Okay. So due to its online presentation and running out of time, okay, just discuss with your neighbors. Can you guess what is this place? In the year 2003, it was like this one. This is sea, this is land, no doubt. But what is this place? Something you can see here. The name is mentioned. Okay, no problem. Now I will show you how it is. Now it is like this one. It is Dubai Palm Island. Okay, it looks like a palm tree, so it is Palm Island. It is just an example, only one image. Okay, so nearby there are a few more events also of same type it is there. And one more image, October 2003, the place was like this one. And these images I have taken from Google Earth. Google Earth and Google Map almost the same, data same. But Google Earth is having some other features, something like this one. The previous data we can see. 2000, see, I said to you about something which we can say for one. See, from 2003, I have taken 23, that was like this one. Now it's here. This is the capital city of Qatar. Okay, it's completely high-rise buildings, all high-rise buildings are there, metros, electric, all sorts of things, everything it is there. Oh, thank God. Oh, now, this is an Indian city. In the year 1700, it was like this one. Okay, can you guess? Okay, I will show it to you. It is Bombay. Bombay is also artificial. Okay, so nearby natural it has grown, but apart from that one, inside this also they have put sand and they have constructed the city. Okay, and here, so what triggered in our mind when inside the sea put a lot of sand and construct a city, when there is a need of water, why don't we take water from the sea and put it inside land? Water from the sea can be taken and put it inside land. But the point is here. Okay, here the water, it is sea water. Okay, salt water. We are see, okay, so it looks like a cup, it looks like a reservoir, right? Okay, so the part what I'm like this one, so many places which we have identified, we have calculated the volume. Okay, so anyway, here the outside red color line I have drawn to you this one, and this is called the, actually for circle we will call circumference, or for a perimeter we will call for rectilinear objects. No word is there for this one, because no such thing is, okay. So we will use the same word, perimeter. Okay, the red color is the perimeter. And here there is a line, yellow color line running across. Okay, so if you see this yellow color line, this tells the elevation details. You see the down here. Okay, here you see a graph. Okay, this shows the elevation. So you can see how much is the depth. Here it is mentioned in terms of feet. It is mentioned 5,000 feet. Okay, 5,000 feet means it is from mean sea level. Not from this one, it is not inside here 5,000. Okay, so what is the height at the top? What is the height at this place? For example, bottom, So what is the height? What I am showing you here with that I will draw. Okay, that means what I will take blue color, light blue. Okay, so here, if you see here, this place, it is same corresponds to, for example, maybe this place. Okay, that means this much height water can be stored here. That means, okay, so if we construct a dam here, that means close this place. Okay, water will be stored up here. According to the, what is this, the height level, it can be stored. Okay. So to calculate the volume, now the question is, what is the volume? Earlier I said, the table is rectangular, but what is the surface area? The upper part of the surface area of the rectangle, we start to measure and we start to calculate, both will give different answer because of the shape. The corners are not pointed. Okay, so they are some smooth, because of safety purpose, it is something smooth. Okay, even the mobile phone what we are having. Okay, so it is rectangular. Immediately we will tell rectangular, yes, it is rectangular, but the corners are not, what is it, sharp. Okay, for safety purpose. So what is the area? It will differ. So what we calculate and what we measure, both will be different. So here also we have to calculate. We cannot measure. It's difficult to measure. We can measure only the outer edge. Okay, to measure this one, the idea we can use, and before that, here, what is the architecture? What is the idea of the project? Here is the Gulf of Oman. It starts from the bottom right, and water needs to be stored in the mountains. So we have to pump water to this one. The distance between Gulf of Oman to the nearby mountains, it is called Al-Hajar Mountains. It is nearly 40 to 46 kilometers. 40 kilometer will take. Okay, 40 kilometers. So not by just a single pumping we can do it. So by various stations. For this one we need a huge amount of energy. So can be generated from solar and wind. Okay, so whichever is possible. Okay, so already we are getting water, no need to worry. For example, when there is no wind, when there is no solar, no need to worry about this one, no need to fill the reservoir now. Okay, so but once we start to fill, once it is filled, okay, after then whenever, always there will be water, the entire flora and fauna, everything will change. Okay, so at various places, here the solar plants and windmills can be used to generate renewable energy to pump water to stations, and it will be put it here. When the water is here, we can open it and it can produce again energy, hydro energy. Okay, so when we are having excess energy, can be put it into grid. And the water hydro energy, this water can be gone to the nearby villages, nearby vegetation region, vegetation area, because it is not turbid water. It is a pure water now. Sea water converted desalination at various places, then it is a pure water. It is not a wastewater. Okay, so it can be used. So even if excess it is coming, it can be diverted to the last station and it can be recycled again and again. Can be cycled again and again, and it can be used. This is the idea of the project. This we have done as a prototype, as a design model, running model, working model we have done. Okay, so here is the schematic diagram of this one. This clearly tells that from the Gulf of Oman, so many stations, water will be stored, then put it in a dam, a reservoir, not dam, reservoir, and then water will be opened. The excess water will come to vegetation or it will be circled back, and it can be used for agrivoltaics. Agrivoltaics idea also is new, can go through it. Agrivoltaics, the word agrivoltaics, remember this one or this one. Okay, so here is the study area. You can see this one. This is Gulf of Oman, and this is the part, the place where I am now. Okay, so nearby this area, here, you can see here, here, this region, okay, here. So the proposal area is here. This distance is 46 kilometers, 40 to 46 kilometers, and it is proposed. So the drawbacks, like even though there are solar, what is this one called? Solar energy, I said. Okay, so here it is full of, for example, if you see here, this is full of, this area full of desert area only. Okay, so then and there will be wind. So what will happen? Dust will be there. When dust is there, solar panels will not work. Okay, here it is mountains. Here also we can keep solar panels. For that one, the shadows be a problem. So we have published a paper about this. You have calculated. So immediately we ask, what is the sun? Where do sun rise? Immediately we will tell it is east. But actually, east means the earth is tilted. 23.5 degree. So the maximum angle for deviation is 23.5 into 2, it is nearly 47 degree difference is there. So that means today we construct a place where it is very good, but within 2 or 3 months, that place will be completely in shadow. So for that reason, a model has been calculated. So this model for every place, it will differ. You can see here. For example, the model here is, so here we have done it for this area. Okay, the logic is same. So use the same logic to keep solar panels here, but the value will differ. Formula is same. The formula is same. Theta equal to tan inverse A by D. This formula you can calculate. This will give a number. Based upon the number, based upon the location, what we want to take, which angle is suitable, we can take. The idea, see here, this is Tropic of Cancer. That means sun comes up to here. Sun will not go here. That means above, if a person is in Delhi, if he can never see sun exactly above his head. Okay, so we are here in Tamil Nadu, especially in Madurai here. Okay, so 2 times. So when sun rises here, when sun rises here, sun rises here, sun rises here. Okay, we can see that on that day, we can see above at a particular time, sun is above us. Then sun rises here, it goes here. Then equator, then up to the Tropic of Capricorn. Then again it comes another 3 months, another 6 months, again comes here. So second day we can see. In a year, 2 days, we can see sun exactly above us. But those people who are staying above the north of Tropic of Cancer, or south of Tropic of Capricorn, they can never see sun exactly above. Okay, they can see in the front. You understand? I hope so you understand. Even today you go and see, you can never see the sun at the exactly above your head. Only you can see it travels in front of us. Okay, so the model can be taken, the value will be different according to the place. Even it cannot be put into a formula. We cannot put the latitude, longitude to find whether this angle is okay or not. It should be personally calculated. Then comes the wind energy mapping. Okay, so because of huge area, the area is huge. The area is huge place is there. Okay, with for safety measures and all, it can be used for wind energy. Okay, so the point is anyone is not there. The other one, with the help of the other one, it can be able to generate the electricity. Even if it is not, we can wait. That's the only thing we can do. Okay, so. With the help of classification, Euclidean distance is enough. Euclidean distance is just our ordinary distance. How we will find the distance between 2 points. Maybe in 2 dimension or 3 dimension, 4 dimension, we can be able to do classification. That is enough for this type of mapping. Because we don't want what is this plant. Okay, in India, in forest, I said, what is this plant? Okay, so I don't want this plant, I want to remove it. Okay, that we can do it. But here, we want only this one. Okay, so what is the, in that place, plant is there or not? If plant is there, then whether it can be removed or not, we can construct or not, wind energy can be measured, mapped here. Okay. Agrivoltaics mapping. Okay, same like the idea is, so I don't wish to go into this one. Now the idea, how to calculate or measure the perimeter circumference of a reservoir. Okay, the perimeter here, whether it is calculation or measurement. Okay, we'll see that one. How to calculate the volume of the perimeter. So here is an explanation I have given, but I will show it to you here. Better here. Okay, so how to calculate the volume of the reservoir. First, assume that we have one reservoir. Already I have shown to you that same reservoir. Find the elevation of the top layer. First, the point is, for the above layer, above surface, for that perimeter what I have given to you, find the surface area. Okay. So, there are many ways to calculate the surface area. In Google Earth, because I have done everything remotely, in Google Earth, because I did not have visited that place and I have taken a scale and measure. I did not have done. Okay, because of so many reasons. Okay, I don't have provision there, I don't have materials. Okay, travel to that, so many things. Only with the help of Google Earth data, I have calculated all these things. That is the new technique. Okay, so earlier days when we don't have Google Earth, Google mapping, we have to go and we have to personally analyze, but now not that one. Okay, so that is the idea which we have to learn from this one. And what I said, elevation, it is available in Google Earth, I have taken. And please note that Google Earth, it is a free version. So, okay, it is somehow genuine, we can take that one because I am not with this data, tomorrow I am not going to construct immediately. There, personally, people will go and analyze. So the exact perimeter they will find. So for me now, I have the layer, the top layer, the surface area I have, the perimeter I have. With the help of perimeter, now divide it into smaller quantities, small quantities. From each of them, take some small points and then find the height, calculate. So height, for example, what I said to you. Okay, so here is the, for example, dam. Okay, assume that it is irregular. It is irregular shape. Okay, so some places one height. Here it is one height. Here it is different height. Okay, so we can able to find what is the height. So I want only up to this level. So this elevation I know. So find the difference. I know what is this height. Find the difference. I know what is this height. So here one surface area is there. Here one surface